everybody. Good morning. Oh no. Oh, 1 second here. Wait, can everyone hear and see me? I think the headphones aren't working. Well, that's interesting. Can everyone hear and see me? Today was an interesting thing with the YouTubes. How are we doing? Can everyone hear and see me? It looks like the audio is going through here, but my headphones are not putting out audio. So that's interesting, but everyone can hear and see me. Sound like a robot? Do I sound like a robot? A little laggy with audio. It's saying, what's weird about it today? Sounds choppy. YouTube says dropped frames. Very choppy. We're gonna try something. Let me see something here. You sound really hoarse. No. Sound like you have a bad cold. No. Yeah, there's something weird going on today with like everything. I don't have a bad cold. Don't worry. Yeah, dropping frames. That's what it's saying is going on right now. I don't know if it's YouTube or what. It says dropped frame, 10% detected. So is it people are saying drop frames, kind of know the industry stuff right here. I don't know why it's saying dropping frames. I think it could be a YouTube thing. Except today everything was weird. Like this 10% detected. Click to read. One moment, we're gonna 10% detected dropped frames. And YouTube on the thing was saying, why are we dropping frames? I don't know if I can lower my bit rate. Restart the stream. If I restart the stream on YouTube, if I end the stream, I can't restart it though, can I? I end the stream and I restart it. Turn it on. Maybe let me do this. I think if I click this, okay, so everyone, I'm probably gonna disconnect. Let me hit end stream on Streamlabs. Let me put this in the chat. If the stream ends, I will start a new video. Okay, now it's not saying drop frames. Do I sound normal again? For some reason, my audio thing was being weird, and I don't see dropped frames on here anymore. So I don't see. It says excellent condition on YouTube, and I don't see Streamlabs saying drop frames anymore. So do I sound normal again? Still choppy? We'll wait a second more. Don't sound normal. Yeah, and I don't hear myself via the thing, but I can see the audio coming through. Okay, audio's still bad. Okay, I'm gonna try ending the stream here, but don't leave. Don't leave. Okay. I'm gonna hit end stream. I might have to send an announcement. Okay. Okay, I've reconnected. So I've reconnected. I just ended the stream, restarted it. Do we sound better here? How do we sound now? How do we sound now? No, shouldn't be the voice modifier. Unless, no, it doesn't say it's on. We're still choppy. I think my, what is going on this morning? This is the only third time in the history we've ever had trouble. It was a weird morning, like Streamlabs was a bit weird. Yeah, could be YouTube. According to Google. Yeah, no, that's what I don't think it's the mic. I wonder if it is. You know what I could do? Let me do this. 2 seconds. I'll have to address this. Let me see. No. 2 moments. I have to change something here. Get a backup mic. Give me 1 moment. I'll try the backup mic. Sorry everybody for the technical issues this morning. Add a new source. Here we go. Okay. 1 moment. I'm adding backup mic.
Okay.
Okay.
Okay, That's so loud. Okay, can you hear me via the backup mic? Oh, man. Okay, so it totally was the mic. We had weird mic issues. And so audio levels look to be good. So sorry, everybody. Sorry for the technical. I've got a backup microphone. I'm going to have to totally look what's going on with the Go XLR. Sorry. Sorry, first 5 minutes of class was technical issues, so I can't use this mic today. So that's why I have backup stuff, just in case. Sounds, do you like this mic better or worse? Watch everyone be like, we like this mic better. I'll be like, no. Very loud. Is it good loud? I don't have limiters and stuff on my voice right now. So, and I have to make sure. Tell me if it's too loud, too quiet. I'll have to adjust it. Give me 1 second here. I need to get the other screens going with it.
Okay, you shouldn't. Gonna mute.
Okay, I got this mic on this screen now, so we're good to go. Okay, so I think all the mic, I got the secondary mic right here. You can see, there's the secondary mic. Okay, so please tell me at any point if it's too loud, too quiet. No, that it should have went back to robot when I went to the screen, but now it shouldn't because I had to change the input on this screen. So we're not using this mic, even though I think it'll be like I'm talking into it. Something weird happened with the Go XLR this morning. I have no idea, but I'll need to look into it. I'll probably just need to reset it. But yeah, I should have realized it was the Go XLR. That's why we got backup mics. Okay, let's do it. Let's hop back. Thank you everyone for bearing with that technical issues. But that's why you have backups. Got the Yeti Blue mic. So just backup issues. You got the Red Bull. Probably a bad question, but can we periodically on the coding exam? But can we work periodically? You can work on it. Yeah, I mean, yeah, that's Ryan. Good question right there, Ryan. You can work on it any point you want. We can't work on it in class together. And please tell me if I'm too loud or too quiet, because I'm totally teaching from new angles right now. We can't work on it in class together, but I wonder if I can just. Wait. Whoa! Shouldn't do this because I'm gonna get like way confused. 2 moments. Oh, it's gonna be just. Oh, look at that. There we go. There we go. Now I'm never gonna get it back into place. Here, wait, 2 seconds. I'm doing this for my own sanity. There we go. Other screen will probably look crazy right now. So, oh yeah, it doesn't have to happen in one session. It doesn't have to happen in one session. If I keep seeing the microphone in the view, I'll keep trying to talk into it. And then please tell me if I'm too loud or too quiet. Like if you guys are like, whoa, earphone warning. So we are going to do some test review today, and I plan to do the Kahoot, I think at 2 p.m. So 2 p.m. Kahoot, 2 p.m. Kahoot. And I'm going to put 320 and 474 together for the Kahoot. So 320, 474 Kahoot. You guys got it. I'm figure out what's going on with microphones and stuff. Yeah, I bet if I reset the computer because I think the driver's just loaded odd. Let me. You know what? I wonder if. Okay. You know what I should have done? I should have done this to start. Watch this work now. Okay, 2 seconds and then we'll be 100%. Does this sound normal or choppy? Can you guys hear me? Do I sound normal or choppy? Do I sound normal or choppy right now? Should have just done that. There we go. Okay. Should have just turned it on and off. Should have just turned it on and off. Should have restarted the app. So that if I just restarted the app, that would have done it. So, man, well, thank you. You know, it's gonna be really interesting because I want to see the difference between the two mics. I just did that for a test, just to see the difference between the two microphones. So, sorry about that. Sorry, and this has a limiter, so that way I can't talk too loud or talk too quiet, which I like about it. So it's got all the fancy, and I just had to reset it. And let me see, can I hear myself in my headphones now? Because that way I can hear what you guys are hearing. And I can hear myself in the headphones. I should have realized when I couldn't hear myself, and this also, I can put it right up to me, talk right into it. Perfect. This mic sounds better. Good, because this is the there's a market difference in the prices between these mics. Okay, 10 minutes in. Let's get started here. I do have to change one thing though. Let me quick change the input. A moment. Audio, 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 audio. Audio, 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 audio. Okay, there we go. We got it. We are on audio on this also. You guys are hearing my audio test where I just say audio 10 times. Okay, let's get serious here. It'll be recorded, Sylvia. It'll be recorded. So it'll be recorded. So Sylvia, I'm so sorry. I have a Zoom phone call for one of my aunt's birthdays today. So one of my aunts is turning 75. And so I'm going to hop into the Zoom phone call and say hey, and that's at like 4. So it'll be recorded. I'm so sorry, Sylvia. I'm so sorry. But we're going to be doing 320, 474, and 2 works really well because I'm going to finish up the Kahoot between classes. And so Kahoot at 2, it'll be recorded. It's for fun. It's for a little bit of bonus. So you can watch the Kahoot afterwards. I'm going to try to put some test questions in there. There's already some written in. But Kahoot at 2 p.m., it'll be about an hour Kahoot, so, but it will be recorded. Let's do this. So sorry for all the technical difficulties. Yep, still doing office hours after class. You bet. Let's do this. Great job, everybody. Woo, crazy morning starting off here. It is these 20-point Tuesdays, and man, just craziness right here. Craziness on these 20-point Tuesdays. So one topic that's on the test that I don't want people to get lost on is the idea of practical significance. So if you're taking notes on what is practical significance and what does it mean, practical significance is the idea of a number that you can give somebody that actually means something to them. So when you think back to correlation, what can you get in correlation? Like you could take correlation and get what? That would be the practical significance. And this is technically on the next test. But what would be the practical significance? Because we're going to finish up these notes and then go back and review in class today. It was the Red Bull that crashed the stream. What for 20 points? Everyone can put the answer once someone says it. What can you do in correlation? R squared, Brendan, right? Brendan, 50 points. Right there, R squared is the practical significance right here, which is oftentimes what we're trying to measure. And I just wanted to kind of mention that, but we'll talk more about practical significance with other topics because that is on the test, like what is the practical significance? And then when I'm writing questions, I'm like, okay, I think there's a question most people will get. I think there's a question many people get stuck on. And here we go. This is where we ended class. Okay, we ended class yesterday by taking notes on this right here and marking everything in the output. So this is going to be on the next test, but go back to yesterday's lecture. And one thing I do want to mention is, and I'm sorry for the lag on it, but YouTube Stat 201 UTK. If you go and look at the lectures, which they're all in a playlist, which everyone should have that playlist. I don't know if everyone's using the playlist as is, but what I've done is I've gone back through the lectures, and I did this last night because for a while it was not keeping up. But for some reason, it takes a while for the stream to let me update it, but I've now changed the names of all the lectures. So if you're looking to review, you can see where your class starts, the other class starts, and you can see where the office hours are. This class I broke apart into 2 parts because we changed chapters. And so you can see, and I try to do this. I put the star class here for this one. If you want to add more timestamps in the comments below, feel free to, and I'll try to add the timestamps to the videos. So I think this really helps people. And if you're looking to review, you can see exactly when your class is. And we end material at 1 hour and 30 into the class. So sometimes I go a little bit longer, but I'm just talking about the same topic. So whenever class ends, the material ends. Like I don't start new material once we've finished our class time. So once again, check out the videos. I've been relabeling them for what the classes are. So if you're going back to review, you can see literally what topic was covered for the class. You're welcome, Connor. And sorry, I got behind a little bit on this. And for some reason, it takes like a day at least for me to be able to do this. So I think I used to be able to do it like right after the video was uploaded. And then for some reason, it wasn't doing it right after the video uploaded. And then I was like, okay, well, I'll wait a day to do it. And if I don't do it right away, then 3 days pass and I don't update them. And I was like, oh, I gotta go and update these. So I'm trying to quick change. No? What's going on? Okay, let's do this. Okay, so yesterday we went through and we talked about all of this output, which is so huge. You need to know this output. This is next test though. So next test, you need to know this output. RMSE is one of the easiest things to understand. Like when I first learned these topics, I was like, what the heck are these topics? I was like, RMSE? But RMSE, let's break it down. You ready? Root, mean, squared, error. Now it says it's residual standard error. It's also called that. But RMSE literally stands for root, mean, squared, error. What two terms in there for 20 points cancel? What two terms? Philip, 100 points, Philip. Thank you for repeating that in the chat. Right there, Philip, boom, extra. You did something, I like it. And so what two terms cancel in there for 20 points? What two terms cancel each other out? You got it. So if root and square, Brad right there, 20 points. If root and square cancel, what are you left with? If root and square cancel, what are you left with? Think about it. Root and square cancel each other out. So what are you left with? Mean error. Does that make sense to everybody? You're left with the typical miss. So that's what the RMSE is. It's about, on average, how much the model misses. But you might be like, okay, well, why are we squaring it and why are we rooting it? So you'd be like, well, why are we squaring it and why are we rooting it? It literally goes back to the model itself. If you were to talk about the typical miss this model makes without squaring it and rooting it, what would be the typical miss this model makes if you just did the average miss? If you were to not square these, you did like, oh, this is a little below, this is a little above, this is a little above, this is a little below, and that was a lot below. This is right on, a little above, tiny bit below, good bit above, good bit below. If you just did typical miss, what would you get? If you just did mean error, 0. Yeah. So when you square it, Casey right there, 50 points, great answer. Because if you just did mean error, you'd get 0. Because the residuals add up to 0. Because some are above and some are below. So the error in RMSE is the residual right here. That's the error in RMSE. And so you're literally kind of doing like a sums of squared error, but not the same calculation. You're taking the error, squaring it, taking the mean of that, and then you're rooting it to put it back into the units of the problem. You don't want squared units when you finish off your typical miss. You want your units of your typical miss to be in units of the problem. So you square it, because if you don't, you'll get 0. And then you mean it because you want the average, and then you root it because you want back in the units of the problem. Does the theory make sense on this? Like, why would we do this? I don't want everyone to be like, oh, it's just something we should memorize. It's like, well, why do we do it? And I wish I could do written questions because I'd be like, why is RMSE calculated the way it is? I've written questions like that. It's a little nebulous, but it's just, all it is mean error. Like, yeah. And that's what I want to. I want it to make sense. Mila, excellent job right there. 20 points, everyone. Emily and Jonathan, everyone. Emily, Corbin. So I want it to make sense why it's called this. We do not want large RMSEs. Now, this is for practical significance. What? So when you think about this, imagine someone says to you, my model has a typical miss of 5. So that means when they make predictions with their model, on average, they'll miss by 5. Now, that doesn't mean they will miss by 5. It just means like, okay, we used the model 10 times. Sometimes it was high by 5. Sometimes it was low by 5. Sometimes it was high by 3, off by 4, off by 8. Does that make sense? Like on average, like if you were to say, on average, I go to Cookout and I eat 2 cheeseburgers. And someone said, no, yesterday I saw you eat 3. And you're like, no, this is on average though. Does that make sense what it means to have like a typical miss? Like when I typically go to Cookout, I eat 2 burgers. Well, I saw you eat 1 there yesterday. Well, no, on average, typically I do this. Typically, 200 points, Jonathan. Typically, our model misses by 5, and that's kind of absolute value, like plus or minus 5. Does everyone understand what I'm saying about this model? Because I'm going to ask you if it's a good or bad typical miss in a second. Typically, our model misses by 5 when it makes predictions. So it could be off by 5 above, it could be off by 5 below. Well, I guess our model's above it. The point would be down here, and that'd be a negative residual. So it's 5 above our point, or it's 5 below our point. The model's below. This is the model in my hand right here, and this is the point. So the question would be, if we were using this model, football's coming up, football might be back, who knows? Weird world we live in, haha, fun times. When you say 5, what does the 5 mean? It'd be in units of the problem. It's in units of y. Brad, 100 points, great question. So if we're predicting how many wins a football team would have, would 5 be a practical model? So my model, when it predicts the wins a football team gets in a season, is typically off by 5. So I could say, the Patriots will get 10 wins. And they'd get somewhere between 15 and 5 in the season. Like, I'd expect in that range, kind of. Like, if I say 10 wins, I'm usually off by about 5 in my prediction. And 5 means like a plus or minus interval around it. You wouldn't, and don't worry, you wouldn't make a 95% confidence with it. You're just like, oh, well, we'd expect Brian's predictions to be off by about 5. He typically misses with his predictions by about 5, plus or minus. Like, it's like saying, like, I go to Cookout and I eat 2 burgers, but the typical miss is about 1. So I usually eat about 1 to 3 cheeseburgers at Cookout. Really want some Cookout. How would that be practically significant for the football model? Would the football model have practical significance? There should be a resounding what in the chat. No, 20 points right there, Alex. No, the football model does not have practical significance because for those who know football, 5 wins or losses in a season, like a plus or minus interval of 5 is ridiculous. It's an interval of 10. And you'd be like, this model has no practical significance. You're telling me my team will either be one of the best in this league with 15 wins, which I think that's possible. It's like, is it about 15 games in a season? Like right at that, or 16 games? I think there's 16 games. Sports. I should have worn the sports shirt today. I got Rick and Morty on. Wubba lubba dub dub. But then if your team gets 5 wins, then you're like Cleveland Browns or Denver. Trying to name more teams. So you're saying 5 for this particular model NFL wins, but the number would be, yes, exactly, context. There is no number that is good. Like if the RMSE is large in context of the problem, the model, this is literally the point we're covering right here. And so you have to look at it like, what does it mean? You have to think, okay, wait, I typically miss predicting the wins an NFL team gets by about 5 wins. That's too much. But what if it's baseball? Now I typically miss predicting how many wins a baseball team will get by 5 wins in a season. How would that work for baseball? Would I be really good at baseball analytics if I could predict kind of within a plus or minus 5, like I'm typically off by about 5, like I might say, yeah, now all of a sudden it's very, very good. Now all of a sudden, yeah, that'd be amazing. How many baseball games in a season? 140? I don't know how many baseball games in a season. I don't know these things. I really should have wore sports today. How close was I with 140 baseball games in a season? 162? Okay, wow, you 20 points right there. Everyone know I'm 162. So I think you're right, Brennan. Everyone's confirming right there. So if you were to be able to be off by about 5 games, you'd be like, well, I think the team's going to get about 125 wins. And then they get 123. And you're like, well, I'm typically off by about 5. And you'd be like, wow. Now it would have practical significance. Because if you were that good of a baseball analyst and you could predict, like, and typically be off by about 5, like on average, like when you make predictions, your predictions are off on average by about 5. No worries, Sylvia, 20 points right there. I like that you're listening in. Imagine we're trying to predict someone's hourly wage and we're typically off by $100. You'd be like, that's ridiculous. That's not a useful model at all. What the heck are you doing? Imagine if we're trying to predict someone's yearly wage and we're off by about $100. Now all of a sudden this model is super significant, like practically significant, because hourly wage 100 is a huge miss. And you have to think about it in context. So the practical significance is always something you have to think about the context of. I can't state that enough. When you do practical significance, you're always thinking about context. And you're like, does this really matter? Is this important to me? Is this going to, be useful? Can I use this in the business application or in the sports application? So these are the harder questions on the homework assignments. They are not yes, no. I can't state that enough. Any question that says, is this practically significant, should not be answered yes or no. The previous question would be like, yes, it is practically significant to the baseball team because in baseball there are 162 games in a season, and a plus or minus window of 5 with your predictions would be a very small window, and teams could utilize this to figure out how good their team is for an upcoming season. Boom, we just made a case for it. So is there any real uniform thing to judge against it? Just context. Yeah, that's the whole problem. Ryan, 20 points. Great question. You just literally have to go to the context of what it's talking about. And unfortunately, I know I use sports examples, and even I'm not the most sports person, but you have to know like the application of it. You have to understand that industry. So when it comes to like pharmacy statistics, maybe my brother says they're trying to predict if like I don't know what they predict in pharmacy. He's trying to predict like utilization of pharmaceutical techs, and he's usually off by about how many hours they need by about 2 hours in his predictions. And if they were predicting for a year, that'd be amazing to say like my brother can predict how many pharmacy techs they need, and his model's usually off by about 2 hours for a year, like for like different hospitals across, because he helps with, he's like I forget what my brother's title is, but he like does different things across hospitals he used to be in the North Carolina system. Now he's in Virginia. We're going to stalk down my brother now, but don't do that. But he's out there. But if he could predict utilization for different hospitals within plus or minus a few hours, that'd be amazing. His models would be absolutely astounding. But if his models are predicting within, a typical miss of 100 hours for a week, they're going to be like, your models are horrible. They usually are off, like on average, they're very off in what we need for utilization. We can't use your models. So think about them going to my brother and saying, we can't use your models. They have no practical significance to us. All this statistics stuff you do is kind of cool. Yay, statistics. But we have no use for your models. No practical significance. Yeah, no, that's Alex. Oh, Regal. Regal is big into that. Alex, 20 points right there. Regal is big into analytics. Regal has a very big analytics department because it's not just showtimes and everything. It's sales like popcorn and soda and their loyalty cards. So which they've changed their programs quite a few times. But Regal, which is here in Knoxville, I believe, has a very big analytics program. And I know some people who've gone and worked for Regal. So one of my former TAs worked for Regal. I don't know if they still do. I'd have to look at their LinkedIn, but yeah, Regal is very big into analytics, very, very big. So residual standard error is the same thing as RMSE. Please take this huge note. I've gotten people saying to me, Brian, the RMSE is not here. You should know that these are the same thing. So literally RMSE and root mean square error are the exact same thing. Don't worry. Someone will email me and they'll say, Brian, RMSE is not in the output. I'll be like, it's all right. I should time mark this. But like, here, go to right here. There's the RMSE. It's just another name for it. And, oh yeah, 20 points right there, Brennan. You're right. That's Dumb Humvee 8451. And we actually, really, really, really quick story on that. We were talking about that in Stat 201. And one of my Stat 201 students was like, my brother works at 8451, which is the people who do the Kroger Analytics. And then he joined the chat and was talking to us about data engineering. So he was like, oh, I'm not a data analyst. I'm a data engineer, which are the people who get the data to the data analyst. So he's like the pipeline person who gets the data from the customer to the analyst. So he works on the pathways. He's a data engineer, which is a different job than analyzing the data, because someone has to like make sure the data is coming in, and then you need people to analyze the data. So, and he works a lot I think he works in C++, he said. So, and then, it's just, and I think he does SQL and C++. So, I mean, the more you know. And he was just telling us about it, and he was like, oh yeah, statistics and analytics, very important. So it was really cool. Got to once go to the 8451 facility. Yeah. Oh, dude, they are 8451. Brennan is their top tier analytics, and so analytics is huge. The ability to analyze data and make decisions. It's like data points you in a direction. It's like, here's what you should do, and it's just following the data. I love it. And so RMSE, we've talked about a good bit of examples. The model typically makes a miss of about 6 percentage points when predicting response rate. Anything that asks you to interpret RMSE, please take a note. If you're writing down your notebook, which you should be right now, This right here is literally the interpretation of an RMSE. It's not percent. Now, I know this says percent points only because response rate is in percent points. So this is not percent, like it's not off by 6%. We're off by 6% points in our prediction because we are predicting response rate, which is in percentages. And so I've seen that mistake before, that the RMSE is in units of the Y. So remember the previous examples? When I'm predicting wins, I'm typically off by about 5 wins, not percent. RMSE is in units of the Y. So whatever your typical miss is right here, this is in units of the Y. I can't state that enough because I've seen that error a lot of times. Don't worry, someone will make it. And there's another percentage point. I think that's why people get confused, is because the notes have percent on it, but it's just because response rate is in units of the Y. Now I want to pause on this slide right here. My family's from New York. I'm getting ready to talk to them. I don't do that on purpose or anything. But if you notice on this slide, something weird is here. This right here is the format we use to save our model into object M. Nice, Jonathan, 100 points. And we're going to left arrow the linear model with y tilde x, comma, data equals into object M. Now here's the really important thing. This object M right here is actually the naive model. So please notice this right here is the naive model. That does not input any, candy bar. It does not input any variables. So does everyone notice the naive model only has the what? The naive model, I want to see in the chat. The naive model only has the what? I'll start drawing it as we do it right here. The naive model only has the what? The naive model. Background noise like radio. It only pretty much has the y. Well, the y what? The naive model only has the y-intercept. So the naive model looks like this. And you could have points like this. Now this is an x. So this is an xy relationship with a naive model through it. So the naive model is actually the mean of y. So it's very important that we know that the naive model is the mean of y. So that's when political polls, you'll see actual versus adjusted numbers. The adjusted, they do like an adjusted, and I've been noticing they do that in the presidential approval ratings. And I should read about how they do that or why they do an adjusted. I think they might adjust for bias. Like they're like, oh, this organization usually is off by this much, and this organization, but I don't know, because it's all estimates when you do political polls. Like no one knows the truth for how everyone thinks. They might say they know the truth, but no one knows the truth. So yeah, Alex, send me some stuff on that, because I think we're talking about the same thing when I see like the adjusted in certain like approval ratings or surveys, and I don't know 100% why or how they're doing that. Like I really don't. I'll admit ignorance to why or how, because I don't do a lot of survey research, so I don't know why they're making adjustments. So good question right there. Good question. 100 points, Alex. Stumping Brian today, saying, Brian, why do they do this? I don't know. So we have here the R squared. I will say this, and let me just say this. A lot of times people misuse statistics, and I really hate that. And statistics is very powerful. Statistics is about mathematics, and statistics is about data-driven decisions. So people will often cherry pick, that's a fallacy, and choose things that support whatever they believe. But statistics is about a holistic view. It's about looking at the big picture. So you have to make sure when you're doing statistics, you don't just go to a statistic that supports what you believe. And think about this. My dad was a statistician. He worked for like Eastman for quite a long time. So if my dad keeps making wrong decisions at Eastman, is that going to catch up to him? Like if my dad keeps on making decision after decision at Eastman, and the decisions are just like the wrong choice. Like he keeps on saying to them, we should make this product, we should do this thing, this polymer should be harder, softer, I don't know, very quickly. Yeah, they're going to notice after like multiple decisions, like they'll be like, you've made 5 decisions in a row that were really not so good. Yeah, you'll get fired. And that's the way I like seeing statistics, is that when You make decisions. When you say you can explain this much of the variation, which is r squared is the percent of variation in y explained by the variation in x. Very important thing you should know. Let me type it here in the chat. R squared is the percent of variation in y explained by the variation in x. R squared is the percent of variation y explained by the variation in x, or it's how far it gets you to understanding the variation y. When you say you can do that and you can't, and like your model is way off from reality and your predictions are not what you're saying your predictions should be, if anyone is monitoring your statistics and knows how to look at statistics, they'll be like, yeah, you're not doing what you're saying you're doing. Your numbers are, you're making up these numbers. You don't want that. We talked about this earlier yesterday, so it's like review right here, how r squared is calculated. 100 points first person, calculate r squared on this screen. I really need to put this on the file. Thank you for everyone putting practice questions. I've definitely taken some of the practice questions. Big hints there. How is r squared calculated? Who can do r squared on this? Here's some hints. This is the sums of squares total. Here is the sums of squares residual. This, well, it says it right there. That's how to do it. That's how r squared is calculated. Yeah, Alex, 100 points. And so, kind of Stevenson, very, very close, very, very close. It's going to be the total. Now, think about this. This is the total sums of squares. 20 points, everyone. Alex got 100 right there. This is the total. This is what's unexplained by our model. So this is what our model did not explain, which is still in the residuals. Please take a look exactly where this is. This is what our model did not explain. So if this is what our model did not explain, then this number up top, remember, this is what our model did not explain. I can't highlight just it. That's what our model did not explain. This is what there was to explain. This number up top is the mathematics that shows us what? This mathematics up top, which it won't let me highlight. It won't let me. This mathematics right here is the mathematics for what our model does what? The portion of the variation that our model what? Because this number is what our model does not explain out of the total there is. So what's the complement of not explaining? The number up top right here is the portion of variation that our model what's for 100 points. The number up top explains Casey, yep, and Ryan, both of you right there, boom, like that. That's what our model explains, because remember, this is what our model does not explain out of the total. So the complement of not explaining is explaining, because here's the total and here's what it does not explain from the total. So the mathematics here would be what it explains. Just, it's important we understand theoretically what we're doing. R squared is literally the percent of variation in y explained by the variation in x. And look, our model seeks to reduce the sums of squared errors. So kind of good theory stuff. I'm literally, the way I'm writing your test, here's a huge hint. The way I've been writing the test is I'm going to the notes, I'm looking at each slide and being like, can I write a question from this slide? And I literally just go through the slides and write questions based on all the slides. I should go to the homeworks too, but I mean, homeworks are based on slides. But that's a huge hint on how I'm writing the test is I'm going through the slides. So if you're here in class, paying attention, taking your notes, when I go back and start writing this test question, I mean, probably like compute r squared. I mean, I should just take that graphic and be like, compute r squared. It's like, okay, here's the total from the sums of squares total from the naive model. See, it's too easy if I do questions like, which of these, graphic A or graphic B, has the naive model? This is the naive model because it's a flat line. Just so you can remember, the naive model, which that'll definitely be on the final, is the flat line through the model. So you can see the naive model here, and that's the naive model, which calculates the sums of squares total. That'd probably be a multiple choice question with like 4 options to be like, which of the following helps us compute the sums of squares total? The naive model, the regression model, the multiple regression model. It's the naive model. Sums of squares total. So here's are there only 2 tests? There's like 4 tests because there's 2 respondus tests and then there's 2 take-home tests. So you got 2 take-homes and 2 respondus. Midterm take-home, midterm respondus, final take-home, final respondus. Sylvia, 20 points right there. So what we see right here is the R squared is how much we're reducing the SSE. I mean, that's the theory behind it, which is shown right here. It's the reduction in the SSE. And what do we want? We want to reduce it 100%. So correct. This is not on the midterm. Correct. Simple linear regression is not on the midterm. That's going to be on the final. Good questions. And we have here interpretation of R squared. I put it in the chat, but you can also say it's the percent of how far it gets you to understanding Y. It's perfectly fine. R squared is referred to the multiple R squared. We talked about this yesterday. So if I do something quickly, please tell me. But this is literally R squared right here. That is literally R squared. Adjusted R squared will come up later. It's just R squared adjusted for how many variables in the model. More on that in multiple regression. Another R squared example right here. If you can look at this right here, you can understand that months on the job explains the most variation in somebody's salary. And I do want to show you something here real quick. And so let's hop over to the main screen right here. Where's my main screen at? I don't know. Everything's going haywire today. So this is a very famous data set as we talked about earlier. I mentioned this in another class. And although I'm going to do a different type of regression, which we've never seen, and we'll be doing at the end of next week or so, middle of next week, I believe. Start-ish of next week. Middle, I don't know. It'll happen. Middle of next week, I say. I don't want to make predictions, then it doesn't happen, right, on the prediction. Okay, so we need to load reg class right here. And reg class is loaded. We need to do linear model, and we need to predict salary. But first, we need the data set. So we're going to go here to data, and let's do data salary. It's capital salary. Whoops, there we go. And we're going to predict salary from months. And data equals, and the good news is, who feels like the coding has gotten easier? Like when you're looking at the coding, you're like, oh, this got way easier. It's just y tilde x comma data equals. It's like all of a sudden now, and we just do a summary of the model. Oh yes, Casey, 100 points right there. So there we go. And Brennan and Emily, 100 points. Just like chiming in, staying on topic, like it. If you look at this right here, 8% of the variation in somebody's salary is explained by their months on the job. Does everyone understand how if I look at this R squared, I know 8%, I feel like all I do is y tilde x comma data equals. Yeah, it's very common. It's the format for a lot of this stuff. And so it's y tilde x comma data equals. And then I'll literally in class be like y tilde x comma data equals. But great format, I know, right? It's just the y variable, the x variable, and then the data equals your data frame. So if you know that format, you'll be doing a lot of the rest of the codes. And then you just manipulate the object with, like you can make predictions with this right here. There's the predictions. You can do different things like extrapolation check. I think that takes new data. It's going to get mad at me. Yeah, there's no new data. That one also takes a model, but it needs new data. So it's saying there's no new data. Oh, you can do influence plot with this. You can do influence, not influence that. Influence, plot, figure might be too small. That's what I thought. But we are going to look at the linear model here. So there's the influence plot. Let's look at the visualize model. And here's the visualize model, and it's too small too. Now let's remake it, and here's the model. So this model right here is the linear model. You know what? Actually, this model is not too bad because it's homoscedastic, 200 points. It's homoscedastic. It's somewhat linear. It only explains 8% of the variation. So it only explains 8% of the variation, but it shows homoscedasticity equals spread. So the points are about the same thickness. The line looks to be linear. So I'd say it's a pretty good model. Pretty good model. But here's the problem. If we look at gender, and gender is a categorical variable, this is real data. I try to make sure everyone knows this. And just think about what this means. Who here can interpret? Now, this is a categorical variable. We'll be doing this type of regression next week, like specifically. Can you interpret that R squared, though? Can you interpret that R squared for this model? And look at we'll talk more about why this is an indicator variable later on. That's an indicator variable versus the reference level. More on that next week. But you should be able to interpret this R squared using this right here. And that's where you're like, uh-oh. That's not good. Or the last model only had an R squared of this. Boom, Grant right there. Yeah, and this is real data. This is the Harris Bank lawsuit. 30% of the variation in salary can be explained by the variation in gender. And then once again, someone might say, well, maybe it's due to like differences, like men have more months on the job, men have more experience, men have more education. You can add every variable to the model here, and there we go. So now gender is still statistically significant. This model now explains 51% of the variation in people's salaries, and we're typically off when we predict someone's salary by about $338, their monthly salary. When I predict someone's monthly salary, I'm typically off by about $338. So that's what the RMSE or residual standard error would be. When I predict someone's monthly salary, I'm typically off by $338.3. Then we see right here the multiple R squared, which I just gave. 51.09% of the variation in someone's salary is explained by the model. Now there's multiple variables in it, so we're seeing a little multiple regression. But what's really crazy is this coefficient. Now you notice the coefficient here was higher when it was just gender male. So the coefficient changes because there's more variables in the model, but still the differences we observe between males and females is basically what? In their monthly salary. And this is after accounting for people that have the same education, the same experience, and the same months on the job. So these are two otherwise identical individuals. I'm doing a little bit of multiple just for a moment. Two otherwise identical individuals who have the same education, same experience, same months on the job, but one is male and one is female. The expected difference between them would be what? Where the male is expected or more. And this is real data. That's what I love about it. This is from 1978, I believe. But what is the expected difference between them? What is the expected difference between them? It's right there. And that's very practically. That's what I was getting at, Brad. 100 points right there. That's what I was getting at. Like, you'd imagine if it was $2, you'd be like, well, it's $2. Or like, imagine if it was just this. You'd be like, well, that's that. Yeah, exactly. Like, and it's two otherwise identical individuals where one is male and the other is female. We would expect the person who is male to make $481 more a month on average than the female. And one, it's statistically significant for the coefficient. And two, this is a large amount. Like this 481 is like, and this is $1978. So even in today's money, this would be a lot. Like $500 more is like, okay, that's a pretty big difference. And that's why there was a lawsuit. And that's why they lost the lawsuit. I mean, if you look it up, Harris Bank lawsuit definitely happened and they lost the lawsuit. So, and so when you think about the R squared, you have to, its practical significance, you have to say, does this matter? Oh, education. See, look, people might say, well, maybe it's the education. Well, we controlled for that. That's also on the test. That number is now probably 29%. It could be. Yeah. And here's the thing, and this is why I try to tell people, is like these problems are so complex that you have to look at each industry. Like, I just hate it because no one likes my, like, everyone wants soundbite answers. I went into this in another class, but everyone wants like, oh, it's this, it's that. And it's like, okay, we have to have a data set. We have to look at the industry. We have to narrow it down. We have to control for sources of variation. And then we have to say, like, how does it impact this industry? Because there's so much variation in data. And so then everyone's like, are you saying it's happening or not happening? I'm like, it's happening to different degrees. You have to, I don't like blanket statements. I like exactness. I think that's why I like data so much is I'm like, I want to be like, here's where I see this. I don't like the, let's boil it down to a note card of like just a quick statement. No, it's like you have to, data. I like data. That's what I like. So I just get frustrated when people are like, make it simple. And I'm like, there's nothing simple about numbers and data and the complex relationships between them. So here's a really like meh R squared. This R squared right here is only 1% of the variation in response rate is explained by the percent of people between the age of 5 to 17. So that's not that good right there. The F test in connection to R squared. So we can see here that the F test, the higher the F, the higher the R squared, because the F test is the ratio of what we observe being explained over what we expect being explained. Right here, the p-value of a regression is the probability of our model predicting using a random y or explaining that much variation or more. So once again, the p-value is just the probability of our model doing as well or better than we see by random chance. All p-values are using random chance to see if our model could do as well or better. So you can literally, as we saw previously when we looked at the F statistic for it, you can literally use the F to talk about how we're doing, because the F is a ratio of your sums of squares. I know we have that right here. So the F is calculated via sums of squares. So the F is connected to the R squared. Does that make sense? That the F is the ratio of these two numbers. This is something you should know from yesterday, that the F is the ratio of your sums of squares mean sums of squares education over your mean sums of squares residual, and that literally solves to this number right here. These two numbers divided equal your F statistic right here. And with that, that means your F is based on sums of squares, and the sums of squares are what calculate your R squared. So F and R squared are connected. Higher F, higher R squared. Higher F, what are p-value? 20 points in the chat. Higher F, what are p-value? So these are easy questions on the test. I can just throw on there just like boom. Like if your F is higher, what happens to the p-value? The p-value gets wetter. Like say like goes higher, goes lower, stays the same. Yep. And I should have 3 for those. I should say like goes higher, does not impact it, goes lower. I could say if your F is higher, what happens to your, what happens to your slope? And it maybe does not directly impact it. And everyone's getting the answer right. If your F is higher, your p-value is lower. And, but the F does not directly impact the slope. Like I should say does not directly impact, like goes higher, go lower, does not directly impact it would be the 3 options I'd put. And that way it's hard for someone to just guess with a 50-50 shot. And so F is connected to that. Regression models for making inferences. This isn't going to not be that too big of stuff right here. But we see right here our point estimates. We've been looking at this. B0 and B1, I've been calling those regularly. Please go back to yesterday at the end of the lecture when I labeled all the output. That is a super important part of yesterday's lecture. If you're looking for concentrated knowledge, yesterday's lecture at the end when I was labeling all the output, concentrated knowledge. So we can make confidence intervals for these estimates though. And it's so easy. Like you're like, wait, sounds like it's going to be complicated. No, to make confidence intervals, all you have to do is the following. We're going to make our model right here for education. Does everyone see I just made the model? We're going to now make confidence intervals for the estimates in the model with confident. And we're just going to put our model inside of it. There you go. That's it. And I'm going to do something right here. Does everyone see this interval right here? Does everyone see that interval for the intercept? If you see the interval for the intercept, say yes in the chat for 20 points. Because you're going to help me figure something out. 20 points, all these answers. Let's get everyone to 200 today. We got some yeses in the chat. How wide is that interval? Another 20 points. I want you to just estimate, round the numbers, and tell me what is the range of that interval. What is the range of that interval? What is the range of that interval? Round it. Don't do it exact, just round it. Just round the numbers nice and neat number. What is the range of that interval? 400-ish. Perfect answer right there. So what is 1/4 the range? What is 1/4 the range of that interval? What is 1/4 of the range? What is 1/4 of the range? 100. 20 points all those answers for all 3 of those answers. So 60 points if you're following along. So watch this. When I do a summary, the standard error of the intercept is going to be about, how do we know this? We just figured that out. We just figured this out. We just said this number. Let's go to this interval. Round the numbers nice and neat. What is the range of this interval? What is the range of this interval? Round it nice and neat. Don't give me the exact numbers. Round it nice and neat. Hint 44 to 124. Round it nice and neat. What is the range of this? Don't round it too much. Go 44 to 124. 80. What is 1/4 of 80? What is 1/4 of 80? 1/4 of 80 is, what's 1/4 of 80? 1/4 of 80 is 20. Wait a minute. There's 20. What's going on here? It's like now I will say this, this does not work 100%. It works for larger samples. If the sample size is large enough, this works. And let's talk about why this works, how we're doing this. So let's talk about why the trick works. The trick works because of, well, there's those. We'll go back to, we covered that last class. The trick works because of, I'll cover that in a moment. Here it is. Trick works because of this right here. This is why the trick works. Because when you build a 95% confidence interval, the t statistic is about 2. So if you're going plus or minus 2, what is the total width? If you go plus 2 and minus 2, what is the total width? If you go plus 2 or minus 2, the total width of your interval is how many t's? Plus 2 or minus 2 is what?
the total width of your interval would be how many t's? You're going plus 2 t's and minus 2 t's. 4. Yep. So this is going back to stat tool on with 68, 95, 99.7. Just remember 68, 95, 99.7. So watch this. Let's go back. I know I keep jumping screens right now. We're going to go back to the output. And is it, I think it's confidence. Is it confidence? No, it's interval. Is it interval? Stop being weird today, computer. I think it's interval equals, or I don't have to enter it in. Is that right? Yep. I think, nope, didn't work. I don't think I have to enter an interval. I think it will just do the second argument if I do that. Oof. Okay, gotta see how it works again. I forgot the argument. Level. It's level. Cool. That's why there's help, because I can't remember everything. So look at this interval right here on the bottom of the screen. Let's clear the output, and let's do this. 68, 95, 99.7. Every time I do this, the bottom of the interval goes down by almost exactly how much? Every time I do this, I know kind of they are really cool. Like I'm 95% confident. You can just, we already did it for p-values, and now we're doing it for these right here. Yep, it goes down by 20, which is the what? Like look at the output. 20 is the coefficient of the standard error. That's the standard error. So when you look at the notes right here, you're just going down by that much each time. You're just going down an additional one of these. And then look at this interval right here. Every time we do this, this goes up by nearly exactly what? Every time we do this, it's going up by nearly just what? I mean, it's not perfect, but it goes from 3328 to 3427 to 3533. So that's 33, 34, 35, 100-ish. Yep. And guess what? This is 100. Now, here's the thing, is we should understand that when you build a 68% confidence interval, it's about 1 t, and 95 is about 2, and 99.7 is about 3. You don't have to know the exact t because of this right here. This is why you don't have to memorize like, oh, I want to build a 98% confidence interval. So if you want to do that, there's the answer. And the reason it says 1 to 99 is because 98% is between this. Like this is the first percentile, this is the 99th. So 98% is between these. So don't get confused if you put in 95 and you're like, wait, I didn't want a 97.5. It's just that 95 would have 2.5 on either side of it. 95 in the middle, 2.5 on either side. And so it builds the confidence interval like that. You'd say, give me a confidence interval for my coefficients. And it says, I'm 95% confident the coefficient of education is contained in the interval 46.06 to 124.71. So let me put this in the chat. I am 95% confident the true coefficient for is contained in the interval blank to blank. Very, very key right here. I am 95% confident. Oh, so I am blank percent confident. Let's change that because whatever confident are. I am blank percent confident that the true coefficient for blank is contained in the interval blank to blank. But there's a difference right here because we already did confidence intervals, and previously we did I am blank percent confident that the true p-value, and you could say for the test of such and such, is contained in the interval blank to blank. So you have to look at what your confidence interval is for. Don't just go to this and say like, oh, this is a p-value interval because it's an interval. No, we're trying to estimate the coefficients. So this is confidence intervals for coefficients in a model. So confidence intervals, yeah, so it makes confidence intervals for coefficients in a model. But we could go right here. Let's grab this code. And if we grab this code and we go to associate, because we got red class, yep. Now we get confidence intervals for p-values. So I'm 95% confident the true coefficient, look, with 500 permutations, we are blank percent confident that the p-value of the Pearson correlation is between the interval blank to blank. So when you look at this interpretation right here, it's almost exactly what I typed in the chat. It says we are, which is fine. I am, we are. And then what are we talking about? The p-value for the coefficient of Pearson regression. So the p-value for the correlation of Pearson regression is contained in the interval. P-value for the coefficient, p-value for Pearson correlation. Slowing it down. And so this right here is basically what I've been writing, but now we need to know how to do it if we're presented with something like this. And I miss having people write stuff out because Not that I try to make people miss points, but I'm like, I'll say things like interpret this interval right here. We usually care about this. And then people will just say the interval goes from blank to blank. No. What we're trying to do, let's go back to the notes. The whole point of this is we take our estimate and we're trying to figure out the truth, which the notes keep mentioning. We're trying to figure out the truth. The whole goal is to figure out what the truth is. And these holy quantities right here, it's called that in the notes, are like the actual truth. Now, what we have is uncertainty. Please write this for 20 points in the chat. Standard error equals uncertainty. Standard error equals uncertainty. But then we have to know what the standard error is referring to, because there's multiple standard errors. And I will give 1,000 points if someone can tell me the 3 times we've seen standard error. And this question stays on the table so someone gets it. Someone gets 1,000 points if you can say that there's 3 times you have seen standard error. And I'll call out your name, you'll get 1,000 points, because you have to know what is the standard error for? What is our uncertainty in? Does anyone know the 3 times you've seen uncertainty? I'll even show them on the screen so you can get hints here. I'll show you 3 spots we've seen standard error used so far in these notes. There's 2 spots on here. There's 2 spots. Actually, all 3 are on the screen. All 3 are on the screen. One of them is even highlighted. What are the 3 times we've seen standard error? You have to be very specific to get the 1,000 points. They're all 3 on the screen right now. That's 20. I'll give you 100 points there, Emily. RMSE. Wait. Here, Jordan, I'm giving you 100 points. No one's gotten it yet. There's 3. We have standard error for residuals has been said. Residuals have standard error. And what are 3 other times we'd have uncertainty? Now, I want you to think about what uncertainty means. It means like I have an uncertainty in this quantity. So we can have uncertainty in our residuals. And there's 2 other things we can have uncertainty in. No one said it yet. So we can have uncertainty in other things. So we can have uncertainty in our residuals. And then there's 2 other things we can have uncertainty in. Who's going to get the 1,000 crazy points? There's 2 other things we can have uncertainty in. Because we can have uncertainty in the residuals. And there's 2 other things. I don't know what I'm doing singing. We'll give it another 20 seconds. No one said it yet. We can have uncertainty. Grant, right? Grant got it. Nice job, Grant. Yep. Grant is 100% right. The slope and the intercept. Because those are estimates. We estimate the slope, and then we can have uncertainty in our estimate of the slope. We estimate the intercept. So everyone see here, here's the intercept. We can estimate it, and then we can have uncertainty in that estimate. We can estimate the slope, and then we can have uncertainty in the estimate of that slope. Does that make sense right there? Great job, Grant. And I want you to see it, that it's like, oh, wait a minute. Here's my estimate. Here's my uncertainty in that estimate. Here's my estimate of the slope. Here's my uncertainty in the estimate of the slope. So whenever you have an estimate, your estimate has uncertainty, and then just logically think about a confidence interval. Another 1,000-point question, first person to build a confidence interval for the intercept right here. Who can build a confidence interval for the 95% confidence interval for the intercept? 95% confidence interval for the intercept. I think so, Connor. Expand upon that. I think so. Building 95% confidence interval for the intercept. 1,000 points. Who can do that? I do ask for this on the test. These are big questions I ask for on the test that stump people. I'm like, build a 95% confidence interval for the intercept. And you're like, I can't do that without R. How do I do that? Well, 95% confidence interval means go out 2 uncertainties in your estimate of the intercept. So if you're following along, you're like, how do I do this? Go out 2 uncertainties plus or minus 2 uncertainties. So who's going to get the 1,000 points? I've got a good estimate of what it is in my head right now. I know the upper bound pretty well. I got the lower bound too. So who can do it? You're like, wow, they just did that in their head. Or they just, you want to go out 2 uncertainties. You want to go plus or minus 2 uncertainties. You want to go plus or minus 2 uncertainties. Any ideas? How do we go plus or minus 2 uncertainties? Crazy points here. I know someone will get it. There's a big test question. Well, but then solve it. Solve the whole thing. You got to solve it. Put in your calculator. Have calculator out. Open it up on your computer. Use the numbers on the screen. This is a practice test question. I try to remember which practice test questions I ask. You're always free to put them in the practice test questions, but build the 95% confidence interval for the intercept. We should be able to do it like that. I try to make the numbers easier on the test, but you can still type this into a calculator right here. Who's got it?
1,000 points. We'll give another 20 seconds here. But build the interval. Give me the full interval. I need the interval. Grant, you're on the right track. I might just give it to you, Grant. You're on the right track, Grant. You're completely on the right track. Everything you're doing is accurate. I know what you're doing. Grant has gone out 2 standard errors. He's made 2 standard errors. But let's look at the equation Grant and everyone should use from here. So Grant has calculated 2 standard errors. We just need it on the screen. And if we're going to build the interval, we need to now, where's the slide with it on there? Here we go, right here. Sylvia, 1,000 points. Sylvia's right. Sylvia, amazing work, Sylvia. And Grant, I'm throwing you another 1,000. You and Sylvia worked together, got it figured out. And which one was I showing? I was showing this one. Let's just see this right here. Let's go grab this. Let's drop this into R. And gotta go to the screen. There we go. Quick change right there. Ooh. Brad, 1,000 points. Oh, wow. And Emily, why not? Yes, I appreciate that. You both said it at like nearly the same moment. And Mila right there. Good. Okay, I'm done. Crazy points. You are following along. That's interpret it. So you built the interval and interpreted it. Great job. And you all responded within a certain like very quick time. So here's the model, and let's go to Confint. And yes, and Mila is exactly right. It's the true intercept. Mila, excellent work. Mila's interpretation is very accurate. Mila said the true intercept. And please note, these numbers are not the exact numbers that they said, but they're, I mean, look at Mila's numbers, 86.86, and this is 86.69, 87.40, and Mila's numbers are off by just the tiniest amount, and we worked that out without a calculator. I mean, without doing it in R. So this is what we know, is that it's usually about 2 standard errors. If you look at this right here, you can see a standard error here is 0.005. And if you go out 2 standard errors, that's 0.01. So 0.244, and that's basically this. 0.264, and that's basically this. Now it's going to do the exact calculations for you. But you should know a 95% confidence interval is about 2 standard errors above and 2 standard errors below. Is this making sense to everybody? Does everyone understand how you can easily calculate a 95% confidence interval for one of these coefficients in your head, or like with a calculator? This one right here, this one, if you do a 95% confidence interval, what is the upper bound on this going to be? Think, what is 0.5 times 2? 0.5 times 2 is what? And then just add it to 91. The upper bound for this one is going to be, think, times that by 2, add it to that, and let's go ahead and look at that. Let's go make Confint Model 2. And please note, there's some amazing notes in the chat right here. And there you go. Look, we were just saying it, that if you do this and add it, times this by 2 and add it here, boom. If I said 68% confidence interval, it'd be 91.5. So watch this. Let's go here to level equals 68. It's going to be 91.5. Very close. I was off by a little bit, but that's it right there. Who thinks they understand how I can calculate these intervals in my head using the standard error, knowing the 68, 95, 99.7, with how many standard errors I will go out? Like, this is my uncertainty in this estimate, and I go out that many uncertainties based on 68 is 1 time up, 95 is 2, and 99.7 is 3. There you go. That's what you should get from this, is that this is uncertainty in those estimates. Like, this is your friend saying, I'll show up at 6, but I could be off by about an hour. Does that make sense? Your son says, I'll pay you $10,000 for your car, but I could be off by about $5. Would that be a lot of uncertainty or a little bit of uncertainty if your friend says, I'll pay you $10,000 for your car, but I could be off by about $5? You're like, well, I guess they'll pay me about $9,990 to about $10,010. So you'd be like, well, that's a little bit of uncertainty. But if your friend says, I'm going to go buy a candy bar, I think it'll cost about $1, but I could be off by $5. You're like, wait, what? You think the candy bar will cost $1, but you could be off by about $5. That's too much uncertainty in the price of a candy bar. That's way too much uncertainty. Why do you have $5 uncertainty in a $1 candy bar? So it's always a ratio of these two right here when we compare our uncertainty levels. So back to the main screen right here. Sorry, I'm doing a quick transition. And here we are. Okay. So reading this output is very, 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 very important. We've only got a few more topics today. And making the inferences. Okay. So our thing here is when we're making confidence intervals, we use the estimates to figure out what might be the truths. So when you say the estimates, you're talking about the estimates from the model and the output we just saw. When you're doing the truths, that's what your confidence interval is trying to estimate. Like when you're saying, I am 95% confident the true intercept, that's B0. When you're saying I'm 95% confident the true slope, that's B1. Very important right there to know what we're trying to estimate. And so there's the confidence interval, and it's the difference between a population and a sample. Cool slide. And this is a review from yesterday. One last thing, and I'll do this a little quickly because we did this yesterday, is this error term has some very important things about it. The very important things we should know is that the error term needs to be typical and an average distance. It needs to be a certain type of miss. And let's look at what the miss should look like. The miss should be, and this just says the error term for the ith variable in the model. That's what they are, the ith observation, excuse me. The error term for the ith observation, like we pick a random point in our model, like let's look at our model here. We pick a random point like this point. Let me erase the naive model. This is actually a very good model now. So we pick a random point like this point right here. And any random point should have an error that is this. So for our errors, which is just that point right there, when the model misses it, it should be these things. It should be normally distributed. So the distribution of the errors should be normal. They should have a mean of 0 and a standard deviation that is constant. Standard deviation that is constant means that it has homoscedasticity. That means there's an equal spread throughout the model. Mean of 0 means that the line goes through the center of the residuals. And normally distributed means that the model has normally distributed residuals. What does that look like visually? Well, this one's actually a really good model. Let's make the residuals go out a little further, little larger typical miss. This is increasing the RMSE of the model because now my model has a larger typical miss, but it's still a really good model because the residuals are normally distributed around this. They might be a little uniform, sorry, stat people, but they're decently normal. And also it goes through the center. So if you notice right here, it's going through the middle of this and it's decently well described by a normal. Make it a little better here. Sure, it's kind of a weakish model now, but now it's a little more normal because there will be sometimes an extreme point. Also, the spread of it is constant. We drew this out yesterday, so I'm just drawing a little bit quickly. Remember, every class, take notes on these things. This is like a constant spread through the model right here. And then we see that the line goes through the center of the model. So there's a constant spread through the model right here. And this is what we want, is we want good models right here. This model right here has a problem with which of the three parts? I wish I could just have questions appear on the test. So let's do a poll in chat. And this model right here seems to have a problem with which three of these parts. Is it part, let's go to the green, part 1, part 2, or part 3? So let's bring up just vote in the chat real quick, 1, 2, or 3. What do you think? This model has a problem with 1, 2, or 3. This is a great test question right here. I should just grab this from the notes. What does this model have a problem with? 1, 2, or 3? What does it? We're just doing it real quick here, voting in the chat. No, yep. Let's see what people say. We only have one vote. 20 points, all these votes are here. Yep, it's 2. Because, great job. I was hoping we'd trick people because it's not going through the mean. If you notice right here, the line does not have a mean of 0. Well, the line we don't have because this is off of the mean. So the model has residuals that are not centered around it. So that would have a problem there. Oops. We could just clear it or something. This one, let's draw one here, a different one. Sorry, I clicked the black pen. This one right here has a problem with 1, 2, or 3. This model right here, its biggest problem is with the first, the second, or the third part. This model has a big problem with which one? 1, 2, or 3? This model has a big problem with which one? Wait for 2 or 3 people to answer it in chat. Model has a big problem with which one? Which one of those? 3. Yep, because the residuals don't have constant variation. There's unequal spread. You might be like, well, what does this mean over here? It means there's one the spread of the normally distributed residuals are constant. So that means constant spread. So yeah, this means right here that the residuals are normally distributed, which means a normal curve well approximates them. So we should see a normal curve, like these should be well approximated by a normal. And so, I mean, they're kind of well approximated by a normal, but if you notice, the spread's getting larger. So that's the problem on this one, is that there's not a constant spread. There's not one number. So this here being one number well describes the spread. So there's unequal spread. There's heteroscedasticity. And then the 0 here states that we see that the middle of the model, where we would have a 0 residual, is going to be a linearity condition, because if we don't have that, then the model would bend around it, because our model is not centered around 0. So the typical residual should be 0. Like we should, if we average them up, like at any point, like when you average the model here, your typical residual is negative. When you average the model here, your typical residual is positive, because like if you just look across this spectrum, let me see here. I was writing notes. What did you draw that normal curve for? Oh, that is the normal distributed part of the model. So this is the residuals pattern at any point, that the residuals follow a normal pattern. So the residuals are normally distributed. So we should see like the residuals having this spread to them where they're tight around the model and they start to spread out. Like a 68% of residuals are contained within 1 or 2 residual standard errors. And the residual standard error is our uncertainty in the residuals. So we should see 68% of the residuals within plus or minus 1 residual standard error. We should see 95% of the residuals within plus or minus 2 residual standard errors. We should see 99.7% of residuals within plus or minus 3 residual standard errors. So you notice residual standard error is your uncertainty in the residuals. So it works the same way. So you can make confidence intervals for like, I am 95% confident that the residuals will be contained within plus or minus this many. We don't usually do that for intervals for residuals, but you could use your residual standard error to give a confidence interval for the residuals. Like I'm 95% confident the residuals will be contained in the interval blank to blank, because it's uncertainty in the residuals. We don't do confidence intervals for residuals, but you could, because it's math. It's just we have other ways of doing it here soon. And so does that make sense what these 3 things are pointing out right here? Does that make sense what this, and just this says the misses in your model? That's just like the errors. It just stands for the errors your model makes. The residuals in the model are normally distributed with a mean of 0 and a standard deviation that is constant. So we should understand what that means and visually understand it too. Great job, everybody. You want your residuals to be independent. That's actually really huge. In time series, that's huge. You want your residuals to be actually completely random. And this shows it right here, another great graphic. Please note that if we were to look at this point, then the residuals would be normally distributed. And you might say, wait a minute, Brian, I thought you said they should have a mean of 0. Well, if you were to trace over, where does that line about hit? Where does that line hit? It hits right about at 20. And look, most of our predictions are right about at 20, which means 20 would have a residual of what? 20 would have a residual at what? What would be the residual for 20 right here? What would be the residual at 20 right here? Like if these are all our predictions, what would the residual be for 20 if the model's predicting 20 and a lot of our points are on 20? So the model predicts 20, it'd be 0. Yeah. And then let's look right here. This one looks to be right about here, a little below 30. And wait a minute, right here in this model, it's a little below 30. And if you look at that, that's where this model hits. And all of a sudden, those will have a residual of 0. And if you look, these are basically normally distributed. And you can look at any point that the model has normally distributed. Also, you see constant spread. Notice the constant spread across these, that it's the same thickness. This is a perfect model that has a mean of 0, the line goes through it, has normally distributed at all points. So if you draw a normal model over these, and also it has a mean of, it has an equal spread. That's the last one, equal spread of the residuals. So this is a great model right here, really excellent. There's the standard error. I think we only have one more topic in here. Cool. And because here we go to the last topic. I'm not going to go to, I think this is the last topic. I think so. So I'm not going to go too crazy into this. But I want you to understand some things, and don't leave yet. We got an activity, which I'm basically going to give away. If you stay till the end, you'll get the activity bonuses. I'm going to do one of them today and one of them tomorrow, but it's going to be a freebie grade, and you won't have to worry about it. I'm going to put it due like on Wednesday night, but it'll take you literally 1 minute. So stay, or if you do leave, check out the video. So if we take one of the x's, it should be normally distributed. Yeah, and that's the key right here. At any point
That's what it's trying to show, like at any point, if you took any point in your model, and that's what I'm trying to show by going back to here. My drawings aren't the best for these things, but if you were to go to any point in your model, the residuals would be normally, it's technically supposed to be completely vertical when you do this, but at any point, the residuals should be normally distributed throughout the model. Like at any point, your model should have normally distributed residuals throughout the whole model, which is a really hard thing to achieve. But it's like, do we get close to it? You know, all models are wrong, some are useful. Yep. So this is, my graphics are trying to also, awesome, Brad, that's great. And so you want your model to have normally distributed residuals that have an equal spread that the line goes through the middle of, which means they have a mean of 0. So that's what we got going on right here. And this is the last big topic we're talking about today right here, is the standard error. Now, this leads to a little bit of theory questions on the test, and I want us to look at this. The standard error is based on our uncertainty in the residuals. So the standard error of the slope is based on our uncertainty in the residuals, also the sample size, and also the standard deviation of the x. So these are the 3 quantities that control your uncertainty in the slope. So when you think about RMSE, I want you to think about a board. And here's what I'm going to do. I'm going to have a board, and we're going to put you out over Mount Rushmore or over Niagara Falls. I like that better. Over Niagara Falls. So we've got this sparkly lake below you, and then we've got this cliff, and then we're going to put you on a board right here. We're going to put a big board out here. So it's a big board. And now we're going to put little old you right here on the board. There's you. Best drawing ever. Okay, so here's what we're going to do. We're either going to put the nails in the board like this, or we're going to put the nails in the board like this. Now, which of Bob Ross, I wish. Which of those, and it might seem a little bit different to you, but this is what the notes is covering right here. Let me show you, because maybe you'll think wrongly on it. I don't want you to. This is what I just did. Is if you were to put the nails in a board like this, it would really nail down that board. And notice, this right here, the RMSE, when the RMSE is smaller, when there's a tighter typical miss. Does everyone understand that RMSE is typical miss, which is how far out our residuals are typically from the model? We talked about RMSE today. Does everyone understand that this has a small RMSE because the typical misses from the model are very small? Here's typical misses. Like on average, how much do we miss by? It's very small. Here's larger RMSE because on average, we typically miss by more when our model makes predictions. And what would this do? If the board had nails all throughout, like not through the center of it, we would have the board maybe wobble more. Now, you probably want to put nails around the edges of it, but we're just going to like either nail down the center or just put the nails randomly throughout the board, or we could just nail straight through the center of the board, which would just like probably just latch that board onto that wall. I don't know much about nailing things in. But if you notice right here, when RMSE is smaller due to this equation, which you can put on your cheat sheet, it's going to make your uncertainty in the slope wider. When RMSE is smaller, your uncertainty, because if this is a smaller number, then this will be a wider number. If this is a smaller number, this will be a wider number. Smaller. Mila, 20 points right there. Crazy points today. But then let's look at this right here. Okay, with my Bob Ross painting on the screen right now. I'm going to either put in, tell me, which of these would you have more uncertainty in? I'm going to put one nail in the board. I'll put it below you right there. We'll put one nail in the board, or we'll put in like 1,000 nails in the board. Would you like one nail or 1,000 nails in the board? Where would you have less uncertainty, with one nail or 1,000 nails? Where would you have less uncertainty, with one nail or 1,000 nails? Is sample size the next one? Here it is. So 1,000. Notice right here the mathematics that n is on the bottom of the equation. With n being on the bottom, you would have less uncertainty when there's more nails in the board. There's less wiggle to this. There's less uncertainty. So this would get smaller as n gets larger. So as n gets larger, your uncertainty in the board would get lesser. You'd have less uncertainty in the wiggle of the board. So the last thing right here is the standard deviation, which when you think about the standard deviation of the x, it's just as simple as this. Would you like for me to put all my nails in the center of the board, or would you like me to put my nails across the board like this? I've got 1,000 nails now. Do you want me to put them all in the center or across the board? Do you want me to just put all 1,000 nails right in the center of that board, or would you like me to put them across the board? And this is the standard deviation, the variation in the X. Because think about it, if you put them right in the center, there's no variation in where you put them, and you want me to put them across. And so when you look at this right here, you can see the same thing on this slide, that if we put all the nails in the middle, all of a sudden there's a lot of uncertainty in this. But if you put the nails across, it decreases the uncertainty. Does everyone see how this works? Where each of these components, this is our typical miss, which is how far out the points are on the board, which we want them to be very tight. We want to have the points tight. And then this is how many nails we put in. We want more points to nail down our data. And then this is the standard deviation of the X, which is the variation within our X variable, which we want higher variation, more variation within our X. And let me double check. And remember, that's just logic and everything, which we cover by talking about. There's confidence intervals. I can mention that next. Let me mention that. That's the last thing I got to mention. Okay. The very last thing, and stay, because I'm going to give away the hints I'm going to tell you how to do the quiz, and you'll get free points, so don't leave yet. Class is not over. We start on time, we end on time, unless there's microphone issues. What a 95% confidence interval means is not that we are 95% confident that one interval contains it. 95% confidence intervals mean in the long run, and this usually leads to a theory question on the test. When I'm looking through these notes, I'll definitely probably put a theory question, probably, because it doesn't mean I'm 95% confident that this one interval contains it. It means I'm 95% confident that in the long run, 95% confidence intervals will contain the truth 95% of the time. Because one interval, like this interval right here, does not contain the truth. But 95% of 95% confidence intervals say, wait a minute, Brian, this is 96 because there's 100 intervals and 1, 2, 3, 4 of them did not contain the truth. Well, you have to go for a longer run. You have to do more intervals. Because in the long run, 95% of 95% confidence intervals will contain the truth. And it's one interval we can't really talk about because one interval either contains the truth or does not contain the truth. So let's see right here. Let's give away the questions because these are mainly participation. Great job on the notes today. Here we go. Let's hop over to the quiz. I'm going to open up quiz 3. Remember, if you are here, this is a freebie grade. So let's hop in here. Let me change this around a little bit. You know what? Let's make this even easier. Let me go to multiple choice. How many attempts do you get at this? Let's do true, false. Let's change this. Let's put a question from, I'm trying to think of a test question that I wrote. Oh, here we go. Correlation shows causation. Very easy question. Couldn't get more easier than this. You guys can put the answer in the chat. Correlation shows causation. Let's say proves. Even stronger words. Correlation proves causation, true or false. This is the only question on your guys' quiz, so this should be very easy. I'm saving and publishing it now. Wait. 4 points. Sorry, I changed things. Okay, save it. It's being awkward. It's being weird. It's being like me. Okay, so it might be... Why are you being weird, Canvas? I don't like it when the programs I use are being odd. Questions, correlation proves causation, save and publish. It says it's saving and publishing. So I'm going to be, this will come out pretty easy. I was in class today and correlation proves causation. So let me go over to quizzes, activity 3 quiz. And wait, this one says 3 questions, but I only have 2 questions. Edit. Why is Canvas being weird? Save. If anyone has gotten to it yet, tell me. Good job in the chat, false. And that pretty much does it for class time. It's being really weird. Has anyone pulled up the quiz and done it yet? Has anyone pulled up the quiz? And it's saying saving, but it's just doing ... Here, I can show you over here. Are we on the full screen? I think we're on the mini screen. Go to the other screen. It's just saying saving at the bottom of the screen. I'm like, why is it just saying... It says it's locked. Yeah, I think it's the dates on it. Let me fix the dates. I don't know why it keeps saying saving. And then 2 questions. Okay, good. Edit. No. Okay. Details. What is today? We got it. We got like this is the very end of class Wednesday done. It was being really weird. Okay, cool. Ah, check it now. Now it should be playing around my light. June 16th is today. I put it due tomorrow. So please remember that basically if you're here, these are meant to be free points. These are basically participation. Yep. So, and you can always, there are like just extra things in here to go over and to look at. But we try to do as many examples as we can. 100, yep. They're meant to be participation. I'm going to try to do some more of these as class goes on, but they're meant to just be participation. And then during class, we try to do as many examples as we can with the output. And that's the whole point of the activities is to do output. So if we are doing output, I think it's just better sometimes to throw in some output and make sure we can interpret it, to understand the code and what's going on, rather than being like, let's just go through the nodes. I think it's easier to break it up and do some output and everything. 10 out of 10, got it. Yeah. So if you're here and you're following along and you're coming to class, that's the point. So keep following along, keep coming to class, because I want it to be you just come to class, you get 100 on it, you're done. That's, I mean, you don't have to worry about it. Don't be like, oh, I got this thing due Wednesday night. It's like, are you following along? Can you go over the histogram in 2A for the homework that's due today? Yeah, what's that say? Let's do it real quick here. We got time between class. Let's talk about it. Oh, is it the log 10 one? Is it the log 10, I think? Let me look at the due dates. Okay, that's due 16th. Good. And we're reviewing tonight. Simple regression part 2. And that's due Friday night. So yeah, or is that due? That's due tonight. And that's due Friday. And multiple regression is due. I think simple regression part 2 is doesn't have much to it. Oh, did we just, my brain is breaking, guys. Let me look at one thing right here. And then I'll pull this up here next. Is there okay, no, multiple regression has 2 parts, right? Okay, I think we just did all of simple regression, which I'm very happy about. Let me double check. Simple regression part 1, simple regression part 2. Okay, yeah, simple regression part 2 is much shorter. We got that. We got 3 more days. Losing track of time. And let me pull up the assignment. And let's bring it up right here. And here we go. And let's take a look. It's question 2. Where's 2 at? So it's in the movie data frame. Make a histogram of the log 10 of the base. So make a histogram. 200 points today. This is a question. What's the opening weekend gross if log 10 equals 0? Ah, yes. So is that, does Canvas drop 2 activities? It should be, I think it's dropping 2 right now. Yeah, which is very easy to get your activity grade. Just make sure you're here. I feel really bad when people don't get the activity grade. So when people don't get activity grade, I'm like, no. So we already think they dropped out. Okay. And, oh, there we go. Okay, here we go. Okay, cool. So the question is, what is it when it's this value? Am I correct, everybody? It's like, what is it when it's this value? Is that accurate? Now, these are actual movies. The movie database, if you take a look at it, it's actual movies. So you can see right here, we can go to the weekend. Let's go to the big weekends. So you got Godzilla, you got Deep Impact, The Waterboy, Armageddon. So when you look at this, it wants the actual value. Does anyone have any idea what the actual... Oh, you're fine. I didn't take it as yelling. Does anyone have any idea what the actual value would be? If you notice, the values for weekend are in, I think, what is it, millions of dollars. So you've got, like, I'm trying to see if I know any of these movies down here. So these movies, I really don't know any of them because they're smaller movies. I don't know any of these movies. Maybe oh, there we go. I know some of these now. Close, Emily, close. What you can do is you can go right here and you could put numbers in. Because watch what happens when we put in 10. Oops, sorry, we don't want to plot it. So imagine you were to go to this value right here and you say it's worth 10, and let's take the log 10 of it. It's that. Mila's 100% right. It'd be this. And then movies that make this. So a movie that makes, because this is in millions of dollars, But it's not just one. Meal is very specific right there. It's 1 million. Now it is because everything right here, like 900,000 is represented by this. So how much money would this be right here? This is a movie that made how much money? This is a movie that made how much money? How much money did that movie make that I'm highlighting right there? Because think about this down here. Think about this. Think about this. Yep. That's 100,000. And so now what would that movie have as a value of it? What would that movie have as a value when we log 10 it? When we log 10 this, where would that movie be? Where would this movie be if I log 10 it? If I log 10 that value, where would that movie be? And these are opening weekend totals that movies make. Like opening, not total amount it makes, total, like, but opening weekend, like an opening weekend. How much money would this movie make? In log 10 amount. The log 10, because this is in hundreds of thousands of dollars, or millions of dollars, excuse me. This is $0.1 million, which is $100,000. How much is 0.1 log 10? You can type it in. 100 points first person. Answer's right under my nose. The answer's like right under your nose. It's -1 right there. And so is what power do you raise 10 to get -1? And if you do 10, because that's how logs work, it's 10 raised to -1 would be, oops, oh, I have this. That's an error. And so 10 raised to the -1 is that. So that's why you get that. Like logs are weird, but 10 raised to the -1 is 0.1. So when you do log 10 of 0.1, it's -1 because you have to ask the question, what power do I raise 10 to get 0.1? And you'd have to flip it. You'd have to do, when you do a negative power, it does 1 over that. So if you were to do, what power do you have to raise 10 to get this, you'd have to do -2. So this will solve out to -2 because 10 raised to -2 equals that number. So you don't have to backwork logs in your head, but you should have an understanding of how they work. And think about this. We basically have two groups of movies. You have your movies that are like indie releases that got between how much? These numbers right here are between movies that had an opening weekend between how much and how much. These are movies that had an opening weekend between how much and how much. These are movies that had an opening weekend between this much and this much. So you got like, what is this? Between this much and this much. You go up to it. You can say between this much and this much. And the second group between this much and this much. Because we have two groups. Yep. These are movies that made between 10,000 and 100,000. And then if you were to say these are movies that made between 1 million and 100 million. You could do two groups. You could say like you generally have movies that make between 10,000 to 1 million, and then you have between 1 million to 100 million. And you see there's like a modality around, this is not, because even though this is 1 million to 100 million, this is not 50 million because it's log scale. The center of this distribution is more around like 8 or 9 million because, correct, yeah, that'd be right. This is 1 million, and this is 10 million, and this is 100 million. It goes down in 10 scale. It goes 100 million, 10 million, 100,000, 10,000, 1,000. So you see two, like you see indie movies and you see non-indie movies. Does this make sense to everybody right here? Does this graphic now make sense how we're transforming the data right here and getting a log 10 view of it? And so that should help out with what we have right here. That should have it. We'll talk more about transformations tomorrow. You can do polynomial transformations and stuff, and that's where we're going with it. We'll talk about like polynomial and choosing order, which will be on your next assignment. You're welcome. And we'll be doing review today. And so, yeah, you're welcome, Emily. I really appreciate everyone staying, asking questions. Remember, this is like bonus. So like, if you're like, I just don't want, we start on time, we end on time, we don't do any new material after class is over. So you never have to stay after class, but it's recorded, and we just talk about questions people have like on the assignment, especially if I can answer a 320 question between classes. But I'll be back. Stay here for the cool outro. I think Jason, did I play this outro yesterday? Why not? We're playing it again. Here we go, Jason. 5 hours. We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours. This ends now.
Why did he reset? Let me hop over to this screen. We had some tech issues this morning and everything was going haywire, but how is everyone doing? Why did my Crash Bandicoot man reset? He's being crazy. I was going to go over to 20 Tuesdays. We're going to do some activities today to do some review, and the Kahoot is at 2 p.m. And so if you saw it a moment ago, I was calling for some extra credit in the chat right here. So tag people in the chat. This is your extra credit opportunity to tag some people in the chat. So tag people in the chat for 20 points right now. Start saying hello, just tagging everybody. We like to start with positivity, get everyone woken up, being like, hey, how's your morning going? Just saying hello. It's really good, you know. I like the positivity. I like the camaraderie we have. And it's so good. It's just like someone saying hey to you, tagging you. Do you guys remember? This is Brian's quick aside, 1 minute aside. Do you remember when like there was games when you were a kid and maybe you were picked like second or third? I was never picked first. That never happened. But maybe you got picked second out of like 5 people and you're like, whoa. Just that like acknowledgement of you. Someone's like, yeah, Brian, you're like, yeah, I got picked. Yeah, and you're like, oh, and you're like never first. You're like, you get second, you're like, yeah, second place. Second, I don't know. So someone just saying hey to you in the morning, really nice to just like wake up and be like, hey, how you doing? You know, just saying hey to people in the chat. So that's what we always like to do at the start of class. Just get everyone woken up here, get everyone ready for statistics, get everyone ready for business analytics. I love it. Great job. 20 points, all those tagging people in the chat. It is 20 Tuesdays. Our Crash Bandicoot man is going crazy. I don't know what he's done. So everybody, good morning. Let's start doing some activity right here. I'm going to post some activities. This will be a good review for us today. The Kahoot is at 2 p.m. The Kahoot is at 2 p.m. Now I'm going to open up some activities, but here's the thing about activities. If you are here in class, you can always watch them later, but if you are here in class, the activities should be super easy. So if you are here in class, the activities should be super easy. And let's do number 4. Number 4 is going to be, let's go here, Analytics 4. And this is functions. We've done so much work. We've done so much. Let's go to this one real quick, and I'll really revise the other ones. So let me edit this. And let's go here to Analytics Lab 3 submission and association rules. Cool. Do we not have one over? Let me remove the access code and let me put it due tomorrow night. So for people wondering, this is due tomorrow night, but if you're here, this should be very, very easy. So this is due tomorrow night, but if you are here, this should be, you should just get it done. So if you are here, this should be, you just go in, you get it done, nice and easy, and we might do another one here in a moment. So this is going to be some practice and some review. Association rules, that's on, it's not, let me change something right here. Let me change this to be due. Yeah, we'll do association rules today too. But let's go back and let's do functions because that's going to be a really good review. So let me put functions as Analytics Lab 3. And so give me one moment here, everybody. And let's go to, oh, clustering. That's no wonder my brain broke. So here, let's do clustering. I was like, I thought it was on there. Okay. So ignore 2 seconds. Let me put the date. Let me remove the access code. There we go. Do tomorrow night. And need to save and publish. And let me publish. And then let's go back to quizzes. And let's put one due tonight. So I think, is this functions? Conditional nesting and 2 seconds right here. I think this, I have totally confused myself now. That's that. And I keep hearing, how is everyone doing this morning? We had, it's so funny, well, not funny, but we had tech issues this morning with the microphone, and it was really, I was like, oh no. It was like really choppy, and I was worried that we would actually have like a big problem with the stream. So I had this big fear that everything was going to like fall apart, and everything got working. It took a little while. So today is the day of tech issues. Today is tech issue day, and we don't want to make these all due tomorrow night. So let's go into the quizzes And everyone should just see assignments starting popping up everywhere. The assignments are just randomly appearing. It's like in Marvel when everyone just reappeared after Thanos snapped them away. There's just assignments reappearing from the void, and everyone's gonna be like, yeah, it's too many assignments. But do not worry. All of these assignments right here are meant to be that we do them in class, and I just want them to exist so you can see them. And let's start doing them to review here in about 20 seconds. So we're going to start off with the activity, just for a review right here, to practice coding, because it's very important we practice our coding. So let's start off with the activity 3. Who has activity 3 up? You got activity analytics lab submission 3, and we're going to practice a lot of coding right here. Who's got it up right now? You can't find your glasses. There we go. Who has the functions? And let's go ahead and take a look at some functions right here. And you should have the activity open. Is everyone doing with that? And it says, which class are you in? Don't worry, I didn't edit that. But we've got a bunch of stuff right here, and I'm going to give away a lot of the answers. But the important part with what we're doing right here today is we're going to use this. Let's install Robust Base. And you got it? Good. Don't worry about which class you're in. You can just put my class. You'll be fine. So let's go ahead and start looking over everything. You'll need Robust Base, everything good right here, install. You know what's really crazy is in the most recent update to R, they put it that if you have a package that is used, Analytics Lab 3, yep, Analytics Lab 3. So you should see this one right here, R Programming Practice Functions. And did I download the solutions? I thought I didn't. I'm in the wrong one, right? Let me see. I have lost my mind, everybody. Let me go, and I don't want to have the solutions right yet. Here we go right here. Ooh. I need a second Red Bull today. It'll wake me up. Right now, the analytics lab okay, here we go. I don't want the solutions yet. Really? Okay, it just says solutions. I was like, I'm losing my mind because I'm not downloading the solutions yet. Okay, so let's hop in here and take a look. And we have this right here. I love these ones. And we have this right here. Okay, so it's important we know how to do functions because, and this really, really made a big deal to me, is that when I looked back on my coding abilities when I first started to code, I didn't quite understand the idea of a function. And we're going to go down to the cumulative sum one. So let's go to the cumulative sum. And here it is right here. This is the first question on the activity on how to do a cumulative sum. And I need your guys' help right here. So be following along, be trying to write this. Functions with for loops. So we're covering for loops and functions right here. Write a function called cumulative sum that takes the argument x and returns a vector of the same length of x. So we automatically know some stuff we're going to put into this function. All this function is going to do is take an argument x. Does that make sense? This function, let's get some yeses in the chat for 20 points. Let's wake everyone up. This Red Bull's empty, but we're going to pretend it's not. There was a drop left. Get some yeses in the chat for 20 points. This argument, or this function is just going to take argument x right there. 20 points. Vage or not. Great job. All it's going to take is argument x. That's what we want to see in there. So it's going to return something. So let's go here to return, and let's go vector. Like, we don't know what it's going to return yet. We're just kind of making a space for it. So every time, like, what does return do? Here's some good theory. You should know this theory for the test that's coming out tomorrow and is due on Thursday. Return does what? What does return do to a function? It does what? Man, 200 points max today, but we're giving everyone 50 for that. Amazing. All those yeses. But what does return do? What does return do? Stops it and returns that right there. Stops the function, returns it. You got it. It stops the function, returns whatever that is. It says stop. It can print it, but think about it like whatever returns a value and stops it. Yep, it returns that value. So you can ask to return and print something, but return is literally going to stop the function and it's going to return that thing right there, which could be a print. So we could try here like, I've never really tried this. Let's just call this random real quick. Random function. It's going to be called random, or random function. There we go. And we're just going to say return, print, and then I've never tried this, but let's see what it does. Random. I'm wondering if this will do. This is a function with no inputs. random function. Now let's run it. And you see what it does. So you can use a print right there. It did what I thought it would do, is this function takes no inputs, and it just returns the print of random. So this is what it will do right here when it reaches the end. You could do something like after this, but anything after this won't evaluate. So just important we understand what these functions are doing. And we have here that we just have a nameless function, and we want it to be called cumulative sum. So we're just going to do that. Copy paste, your best friend. Use copy paste to just, if you want this function called this, then do that. Look at what this is right here. This is just a what type of what, 100 points. This is a what. You should be able to communicate to someone, this is taking a what. And I think it says it up top. It does. Well, it just calls it that, but it's a specific type of that. It's a vector. 100 points, Sarah right there. It's a vector. Numeric vector to be specific, or like integer vector or some kind of, it's a numeric vector of sorts. Great job. 50 points everyone else, but in Jordan, 100 points, numeric vector. Yep. It's numeric vector. So it's just taking a numeric vector input, and the C right here means concatenate. Do you guys remember when like C was really complicated and you're like, wait, and now you're like, oh, that just joins things together in a vector format. So when you see C, vector length 7, 50 points right there, Andrew. Great comments, amazing participation today. This is what we'd like to see on activities. So it's going to return a vector of the same length whose ith element is the sum of the first, second. Okay, makes sense. So we're just going to return, like think about this. Let's look at this vector right here, and you can see what's going on. In this vector, and I'm going to zoom in. In this vector, the first element is 1, and so this is 1. The first and the second element are 1, 3, so this element is what? 4. How is 10 found? 100 points first person. How is 10 found for the third element of the returned vector? How is 10 found for the first element, the third element? Ginning right there, 100 points. Yep, it's just the sum. Some of those things I have highlighted. Yep. So, yep, perfect. 100 points, all those people, all the way down to Peyton right there. So, great job. 300 points max. I've already given you guys a lot of points, but keep the conversation going. Keep following along. So, we want to go in here, and we want to say for, and we're going to go to do a for loop. Let's go ahead and just take this vector for the moment, and let's call this practice. Well, so remember, when you write a for loop, don't write a for loop. So let's call this practice vector right here. And we want to call this vector, and let's just store a blank space. Well, we're going to store into vector position 1. We need the sum of practice, and we'll go from 1 to 1. Then this will store into vector position 2. And watch, we can take a look at what's going on in vector. And if you look at vector over here, guess what? The next number will be what for 100 points first person only? Next number in vector will be what? If my code is working properly, the next number in vector will be what? 10, Ninton right there, you're right. There we go. It's just doing it's creating this output. Yep. So it's taking the sum of practice 1 through 3. And what have I just written on line 67? Line 67 is my what? And I've just shown it by changing it. Line 67 is my, you got it, skeleton, Adam right there, 100 points. Yeah, skeleton, boom. Okay, so now we're just going to go here to 4. And we're calling that practice. This needs to be X because we're taking X as an input. We could have just called the vector X. That would probably be a better idea. And this is going to store into vector and return vector. What should this become? 100 points first person. Casey, 100 points. I like the emoji. Next I want to start seeing that emoji in the chat. What should that become? Yeah, Nitin right there, 100 points. Boom. What is going to become I down below? You notice what becomes I now? What becomes I now? What's going to be replaced first person 100 points? What's going to be replaced with I? 3. There we go. And almost. Nin, you get 100. Caroline, Toss get 100 too. Great job. Keep answering. Get your 300 today and keep answering. I might give it to more people, but keep answering. Just because I give it to more people, don't stop answering. What will vector do? This is a tricky one. I'm offering 1,000 points for first person who writes this answer. You have to write the full thing for what vector will do. Be careful. don't use the information down here, write it in code. This is where the mistake would be made. First person, 1,000 points. You get maxed at 1,000 today. Adam, you guys are, yeah, it's right here. Adam was first, and there's a small difference. Adam, and this is very important too, I think about things that are on the test. The parentheses means length is a function. So little hints. These right here means function. These here mean position. And these run code inside of them. So just understanding the small difference between how we do the notation, that parentheses are where we do functions. So length is a function. Just small difference. If we do square brackets, that's element length position x. Does that make sense? Like our value length position x and value length. So be careful. If you're doing square brackets, that means position of what you're ever talking about. Does everyone understand the key subtle differences here between parentheses are used for functions, square brackets are used for positions, and curly brackets are used to run code? Like this is the code that will run inside the function. This is the code that will run inside the for loops. This is the arguments inside the for loop function. These are the positions inside of vector x. Bunch of weird noises outside. I need to go back and look at the timestamp, see if I hear that. Okay, so I think this has it right here. I think that's got it. Drop that right there. Cool. Did we do it? We did it. That's it. That's the code. And it's all about following the procedures. It's all about coding your examples. And then I know you're not supposed to write the function to start, but it kind of said, put argument x in here. So we made sure it has argument x. It said return the vector. And then we can do this on anything. It wants us to now run a bigger code on like a set seed, and we'll make sure it returns the right value. So then it has like a bigger thing, or no, does it not? I thought there was like a big thing like, oh, then the run, is it no longer here? Then run the line of code starting with set seed, verbatim, note, for example, the fifth element. Am I going mad, everyone? Did I delete something? I'll tell you the answer to the question. So, or is the chat still? No one said anything for a while. I get worried when the chat stops, because one time, like, we stopped broadcasting. Oh, and we had bitrate issues this morning, too. Oh, here it is. It's in the question. Here it is. Okay, let's see if we get the same answer. I hope they haven't changed the way this function works. Let's see. And the answer is that. And is that the answer? It is. Well, that's the answer to that. There you go. So that's the code you want to run. Let me drop it in the chat. So if you aren't on the screen right now, well, you should be. I got an A. What's going on? When I run the chunk, my vector won't run. Okay, let's see here. What you want to do is here's what we want to do. Take your for loop out of here. So this is just a very small, like, this should look like this. Everything's good right here. Now go to your for loop and store into here X. You might have to send it to me and just do something like this right here. And then this should be this. And you know what we probably need? You probably need do this. I think I see an issue, and I think my code had a problem, because I bet you I can break mine. Who for 1,000 points knows what Brian's probably going to add, which probably is the issue people are having. And I'm sorry, I think I did something. I did it so quick. 1,000 points. Re-indent lines. That's what I want. Okay. I'm going to do this, and I think I can break my code and make it not work the way yours. Yeah. I think that's what people are saying. Yeah, Jordan, right? Yep. That's what it is. So we're going to go here and there. And I did that. There we go. Works now. Yep. That was it right there. So double check your code. Sorry about that. There was a key mistake in that function. It only worked because vector was already saved to my global environment. And if you notice what I did, I cleared my global environment to then see if it would run. I cleared my global environment, ran it because I realized it. I was like, oh, people are having this issue. I kind of quickly stored the vector and created it. and then I forgot to put that in my function that it creates a space for it. And we need to create the space for it before we do the for loop. If your code's not working, send it to me and I can look through it. The solutions are also posted too, so you can go to the solutions, but you have to think about, it's not just writing down the solution, it's like practicing the coding and doing of it right here. Who did this fix anyone's problems to initialize the vector? I think we might see some yeses in the chat. Hopefully that fixes the problem by initializing. Yeah, that was, I realized it right afterwards. I was like, oh yeah, I didn't make the vector. Because I did it so quickly, I made the vector and then I did it and I forgot. Yeah, fixed. Nice job. Yeah. Oops. One error and the code doesn't work. Love it. I mean, I do actually love it. I laugh like, oh gosh, it's so horrible, but it's fun. It's fun to figure out the error with a code. Based on number 7, based on the distance between vector, once your function's working, do this. Okay, so let's go to number 7. Let's practice writing a function here. And I'm trying to drop like possible test questions. That's chunk 7, Q7 right here, distance. Okay. If you can't tell, there's so many questions in this. Please notice that all the solutions are posted for this. And a lot of these questions for the activities, I don't think I've made this clear enough throughout the semester, but the activities show you a lot of different types of problems, and then they often mimic the homeworks. So I try to do a bunch of problems during class. The activities also show you how to do different types of problems, and the solutions are also posted. Does it matter if we initialize the vector inside or initialize it inside the function? Your code will still work if it's outside the function, but if you want to send someone a function, you would initialize it in the function. At least you don't have to worry about semicolons and R. Yeah, you really don't. If you do it in the function, maybe the results would be the desired one. What it'll do if you initialize it inside the function, it'll clear that out, but it's also doing it in function world. So it's clearing it out in function world, not in the global environment world. So I would do it inside the function because it's a computation you want inside the function. Technically work either way. Inside function, outside for loop. Yeah, Jordan, great job. Great answers right there. Exactly. So let's take a look at this one right here. Our first topic in data mining portion of the class is clustering. So there's a little review of clustering. How do we define similar as a choice? So is there any right choice for clustering? Is there any right choice? This is like the easiest true false I can possibly write. You're welcome there, Nin. Is there any right choices for clustering? Nope. There's no right, there's no wrong. Previous lab problems have explored the distance between two matrices. Matrix? Stop being weird, R. Ways to measure how far apart individuals are, but, oh, sure. I don't know. But all have assumed each individual can be characterized by a set of numbers. What do we do if we have categorical variables? If someone is 5'8", has blue eyes, is from Tennessee, and thinks strawberry is the best ice cream flavor. There we go. That's the right answer. How far away are they from someone who is 5'11" with brown eyes, also from Tennessee, who thinks chocolate? Go here and cookies and cream. Better ice cream flavors is the best flavor. One way to calculate a distance between a set of categorical variables is simply count up the numbers of values that are different. Tennessee is the same, but the flavors of ice cream are different. So I'll get right here, just to make it clear. But flavors are different. So these individuals right here are going to have a distance of 1. Write a function called distance categorical that takes 2 arguments, x and y, and returns the number of elements that are different. Verify that your function returns 3 when using v1 and v2 as the vectors below, then find the differences between letters 1 and letters 2. Note that yada yada yada, that the first 2 lines inside the curly brackets for the function should be this, and we're going to turn them into characters. And then this. This way, things are converted to text before comparison so that even if the arguments are numeric rows of a data frame, categorical variables, it still works. Okay, so literally, it's starting right here with this, and it's starting with this right here. And we are given these examples. What should we get if we're trying to figure out the distance these two people are apart? What answer should we receive for the distance these two people are apart? There's a lot of ways to do this. So look at this, look at this, and look at this. What should be the answer? It says it below. What should be the answer for how far these two individuals are apart? Now you can't see the answer. Look at this. 3. Nice job. 50 points, Andrew, right there. It is 3. So
we're going to take these two individuals' answers. For the moment, we can just store them as X and Y. This will kind of help us out right here. And we can store these as characters X and Y. So it's just going to convert it. Please note, I just stored these as X and Y just for the moment, so I can have these stored right there. Now, there's a really simple way to do this. Does anyone know how to go through and check each element to see if they're the same? How could we do each element to see if they're the same? How could we do each element to see if they're the same? And we'd have to be careful because we would almost get the same answer if we did something. We have to be very careful. There's an answer that will look like it's correct. Yep, it's equals equals. If you did percent and percent, you would get the same answer here, but you'll get different answers for different. You wouldn't want to do it. And the reason is because percent and percent will see if the first element's contained on the right is the second element contained on the right. And we're trying to do one-to-one comparisons. We're going through algorithmically and looking to see if the first one is the first one, the second one is the second one, the third one's the third one. So we're not asking is the first one contained over on the right, is the second one contained over on the right. We're asking is the first equal to the first, is the second equal to the second, is the third equal to the third, like that. And what's interesting is you think you'd have to do a for loop with this, but you don't gotta. You have to just do this, and I have to be careful. We're not done yet, but it returns this. Now, these are the things that are equal. These are the things that are equal. So if we want the things that are not equal, 50 points, what can I do now? There's two ways to do it. There's the way I like, which is ridiculous, kind of, but what are the two ways to change this? Or what do you simply need? Yep. Simply, you could just do this, and now what I want to do to this quantity. Great job, everybody. What do I want to do to this quantity now? What do I want to do to this quantity? Because it's trues and falses. And I want to figure out how dissimilar they are. What do I do to this quantity? Which will give me the positions? Which will give me the positions? Which will return 1, 3, 5? Really good questions on code right here. As numeric, we'll turn it to 1, 0, 1, 0, 1. I think so. Oh, who got the right answer? Nitin, 100 points right there. Nitin is correct. I think as numeric will turn it to 1, 0, 1, 0, 1. And which will turn it to 1, 3, 5. And sum will turn it to 3. That tells me how many are dissimilar. Because we're asking what of x is not equal to y, and it's doing a one-to-one comparison. It's literally looking at this and saying this is, like when you look at the code right here, what it returns, it's saying true, this is not equal to this. It's asking, is this not equal to this? That is true. Is this not equal to this? That is false. Does that make sense when you say, is this not equal to this? That's a false statement. Or you could say, this is not equal to this. That's a false statement. This is not equal to this, the whole thing. That is a true statement. This is not equal to this. That's a false statement. Always some mean, yeah. And you can use which, because which will tell you where the trues are. So be careful on the coding portion of the exam. I do ask questions like this. I do ask you like what this will return or like what a which will do or what a sum will do. And we're going to do that today during the Kahoot, 2 p.m. Kahoot, 2 p.m. Kahoot. And so I'm going to have a good bit of coding on there because 320 and 474 have coding questions. And it'll be very interesting to see the differences between the two classes. So I'm very interested in that. I think we've written our function. This is what we want to return. So you could just call this as value. Let's just put it in the return. Not the return, but the return. And that's got it. This is our function. Let's remove it. Let's go to fun. Let's drop it inside of here. Let's re-indent lines. Let's go here. Did I do it? Code. There's like crazy noises going outside. And that's got that. It needs to be called this. We go here to this. We drop it in. We run it. We run it. We run it. Error. Unused argument v2. Oh, ha. X, comma, y. There we go. Well, who could be? Yep. It'll be recorded and posted. 320 is going down. Oh, we should have a competition. Can we do teams on Kahoot? Can we do teams? I think you can do teams. Oh, that'd be so cool. So yeah, show up to 2 p.m. Kahoot and it will be posted. And if I can do teams, we're totally doing teams. Oh, that's so cool if we can do teams. I think you can in the new Kahoot. So here's the function. You can pause the screen where the answers are posted. And let's go grab the code it wants to run the function on. So distance stuff1 from stuff2, and it's a bunch of letters. So we're going to drop the code in here. It is posted to Canvas. This is, I wonder if it says 1006 is the answer. I'll confirm. Please tell me if an answer I post is not the right one. Okay, oof, that's a lot of code. It's easier maybe to just go and get it off Canvas. But, ooh, really? Really? Let me add another answer here. Update question. Okay, might be the different way the randomness is run. But it is now, I'm looking at it. Factor, replace. Okay, yeah, that seems, yeah, that's right-ish. Okay, makes sense logically, but I'm wondering why the answer is, so you got 104? Yeah, that's what the other answer says on here, and I'm getting 1006. Let me try this. Let me go to RNG kind sample dot kind equals rounding. Is it capital? No. Where did we lose it to? Rounding. Really? Why can't I remember? Sample king? No. Sample kind, that's why. Not my day for coding. Wait, NA is not a valid option. I can never remember how this function works. RNG kind, where is it at? Random number generation. RNG version, set seed, RNG. Sample, there it is over here. Sample kind and sample kind. Really? Sample kind, rounding rejection. Was I not entering that in? Oh, because it's capital. Functions need to learn that capital letters are not that big of a deal. Let me see if I get the other answer this way. Yeah, sample king. I just saw that too. Man, it's just one typo. That's the way things go. Let's see here. And so let's go here to rounding. Okay, good. I think it's fine now. Those are warning messages. We're good. 104. There we go. There we go. It's rounding. If you change it to rejection, which is the way it, and that one does that. And then there's that. So if you literally look at this right here, it's the two ways random numbers are generated via either rounding or rejection. So you guys are probably using rounding. And now when I rerun it, I'll get the same answer. But I put in both answers depending on RNG kind, which definitely, and so I updated it. No matter what, either answer works. I updated the answer key. So, but we'll either answer works. I just updated it. Like I first updated it and then I saw where the error was. So this is just, it's basically to explain why this happens again, because we should know why this happens. It's like when we play Xbox or we play PC and we load up a Minecraft world, everyone who plays on Xbox will get the same Minecraft world with the same seed, but everyone who plays on PC will get a different but same world to PC people. So it's like, here is your Xbox world, and you'll always get this result if you're using rounding and setting your seeds. Here's your PC world, and you'll always get this world right here if you use these seeds. So you'll always get the same result with your RNG kind set to a certain thing and using certain seeds. So if you set your RNG kind, you'll get the same results. And I'm going to have to watch out with the take-homes. But does that make sense to everybody? Like, the RNG kind sets the way the randomness is computed, and once you set the way the randomness is computed, you will get the same results every time. So hopefully that makes sense. Like, why are we getting different results with set seed? Because the randomness is being computed differently depending on if we choose rounding randomness or rejection randomness, which then you can read about the different things over here. And I always forget how to change it, but that's why it happens. So we should know the why of what's going on. It's the way R generates random numbers. Now there's alarms outside. Woo! Fun today. Crazy days. Next question. Based on number 13, function to calculate tips. So we're going to do a function. Oh, I love this one because I used to be a waiter. And we're almost done with this. We've done so many problems already today. So number 13, function to calculate tips. So let's go here to tips and let's take a look. This one's pretty complicated and it's really good because we can calculate different tips. How did I go that low on this function? Okay, write a function called find tip. And so the function is going to take here a lot. We'll either answer, yep, okay, we got that.
we're going to take all these arguments: bill, tax, percent, and pre-tax. Now, once again, we don't usually start by writing our function, but these things right here are going to give us some advice on what to do. So I'm going to go right here and enter a chunk just because I like to see things at the same time I'm working on them. And it said write a function called find tip. So I'm going to go right here and we're going to put in here find tip, or we're going to go to fun. Then we're going to go find tip, bill, tax, percent, and pre-tax. Now, which of these have defaults? Which of these have defaults? 100 points first person. Which of these have defaults? I think we're good. I think I know the answer. Yep. Which of these have defaults? Do any of them? Which of these have defaults? Pre-tax, yep. Optional argument defaults to true. There we go. So we've kind of got the container right here, 100 points right there to Sarah. So we've kind of got the container, 20 points everyone else, and pre-tax equals true. Nice job, Jenny, right there. And we've got everything we've written out. We're good to go on the container for it. Bill is the amount of money people spend. Okay, let's go over here and let's start writing our function. And I think I know all the ways this one works. So bill is like someone comes to a restaurant, spends 20 bucks. Does that make sense? Someone comes to our restaurant, spends 20 bucks on their meal. Totally understandable. Tax is the sale tax charged on the bill. So this is literally the calculated tax. We're not going to calculate tax by doing a percentage. It's literally to say there was $3 tax on the bill. It's just how much tax was on the bill. The percent right here is the desired amount that people wish to tip. Like someone's going to say, I want to tip, and they'll say 20%. So they want to tip 20%. And the pre-tax is going to be they want to tip on either this or this. If pre-tax is true, then what should they be tipping on? If pre-tax is true, what should they be tipping on? How much money would they tip on pre-tax? So what should our function return? We're going to make our lives easier. Let's put this to $2 here. It's a little bit easier. They're going to tip on just the bill. Yep, they're going to tip on just the bill. So we can calculate the tip someone would get, and they would tip $4. Now, if they tip on if pre-tax is false, they'd tip $4.40. It's a little bit easier to, $4.60 if you do that. Just, yeah. So now, any of these numbers work, whatever they are. We're going to go here to if, you know what we can do? Pre-tax, we can store down here as the following. We can go right here and go pre-tax, and then we can set it this way to true. Pre-tax is true, so we can say if pre-tax, we don't even have to evaluate it. We can run the code that we would get here. Let's say tip, store into, and then let's say bill times percent. And let's look. Pre-tax is true, and someone's tipping $4. And then let's try this. What do I need to connect on this? What do I need to immediately connect to get the other option? You guys should know it like this. You should be like, has to be connected to it. It has to be right on the end of that bracket right there. On that curly bracket. Else, boom, right there. You got it. Else, and you notice it highlights. It's a code right here. Going to connect this. And then we're going to take right here and let's go and add these two together. Now be careful. You want to add these two together inside of here. And let's change this to false. And then let's run it. And let's just check their tip amount now. Yeah, there we go. Does that make sense? Now it's going to add together their bill and their tax. Now be careful. I'm pretty sure we're going to get an error if we do this. I mean, not an error, but we won't get the right answer. So yeah, that's saying you should tip $20.40. That's not right. Imagine you punch this into your calculator. It's like a thing where you just enter in the numbers. It's like, you should tip $20.40 on your bill. And you're like, my bill is 20 bucks. So now this is a problem because we want it to evaluate that it adds these numbers together and then finds 20% of these. And this if someone says, I don't want to tip on the pre-tax amount. Someone will either choose to tip before tax or after tax. If pre-tax equals true, they're going to tip on the first amount. Tip on tax rather than the bill. There you go. Oh, you could tip on just the tax. That would, yeah. And then for a lot of states, if you just, depending, what should people tip? Like, what is the right amount to tip? Like, let's say it's just good service. I'm not saying stellar service because that's a whole nother thing. Like, if your waiter or waitress gives you amazing service, that's a whole nother ball game. But what is like the amount you would say to tip? I'm with Sarah and them. I agree with like Sarah. And there is like, I think about 18-20%. Like like if it's like $21, I'll put 25, which is like it's like a 20%, 25% tip. So yeah, and it's all differences, like differences in culture and everything like that explain how much people tip, because I think in a lot of like if you go to like France and stuff, people don't tip because I think it's like built into the bill. I think it's like tipping is not, maybe it's changed, but that was at least like 10 years ago. I mean, I've never been to France, so in current world situation, hope together one day. Haha, fun times in the world. 20% then rounded to the next dollar. Yep. And it really depends too, because like if you buy like a $500 bottle of wine, like tipping $50 on that would probably be really nice. So like, I mean, $500 bottle of wine, $50 on that is, I mean, I'd love that. I used to work in a fine dining restaurant. If someone was like, I'll have the $500 bottle of wine, then someone gave me $50, I'd be like, ooh, that's awesome. And it's only 10%, but you know, it's like the amount of service in a wine bottle. And I'm not a sommelier, wine expert. I'm not one of those. I just grab the bottle and hopefully open it without pushing the cork into the wine. Done that before. Like, oops, here's your super expensive bottle of wine. It's old bottles of wine have really bad corks. I know some waiters and waitresses probably know what I'm talking about. Like, you get an old bottle of wine. I'm just putting inside of a function here, right here. Oh, we already had a function. Well, sure, let's change it over. Yeah, so you get these really old bottles of wine, have really old corks, and really annoying. Don't like them. Okay, so our function's not done yet. I should have probably coded the rest of it, but I think we've coded everything we want here. But people are going to do, oh, we want to remove these now. Because people are going to enter in those. Yeah, like Madeline, right? Agree. Like, you should give a nice tip for the service. For the amount of service you get, people should, I think, should tip accordingly. Personal opinions with Brian. So someone might enter in a percent that we want so that your function will work on percentages that are written as decimals or as numbers. So when someone enters in a number, let's check to see if that number is contained between what and what. There's a lot of ways we can do this, but we should probably, because if someone says they want to tip 0.1, what do you think they mean? Or if someone says 0.2, they'll be a nice person. I mean, that's what I think people should maybe consider around there for like 0.2. If someone says 0.2, yep, between 0 and 1, because 0.2 probably means 20%. I don't think they're saying I should tip 0.2%. So we're going to assume that someone is wanting to tip 20% when they say 0.2. So if, let's say here, percent, if percent is less than or equal to 1, and, yeah, we could do it this way. And, where's my end at? I'll learn where end is at one day. And percent is greater than or equal to, that's right? Greater than or equal to. Greater than or equal to 0, then this is a really absurd way of doing it. Dr. Pishu would get mad. Do nothing else. No, wait a minute. No, we won't do it this way. Yeah. Else, take percent and store percent as percent divided by 100. There we go. So this right here will evaluate the percent somebody puts in. And we need one more thing right here. We need to go to the end of our function, go to return tip. This will evaluate the percent somebody puts in, and if they put in a value that is less than or equal to 1 and a value that is greater than or equal to 0, it'll do nothing to it. That does nothing to that. Nothing at all. And else it'll do this. So I could have, it's just important that this is the important part. We don't want it to do anything here. Just sure, move on to the next part. What if percent is bigger than 1? Yep. So anything outside of this, I mean, if someone puts in negative, we could put in error message. So we could do things like this. You could put in stop. Oh, no, wait. If percent less than 0, and then we go right here and we say stop, and we say you cannot put in negative percents. If class percent
is not contained in the vector integer numeric, and then we go to stop, and we say please % should be a number. So we just added in a bunch of like error messages and warnings. Your receipt tells you what percent you're paying. Sometimes I said, yeah, that's a good way right there, Scott. Like it's, if you just double that, a lot of states it's like 8-9% tax. So if you double it, you're doing like a tip of like, you know, like, and that would be pre-tax. So you're tipping pre-tax when you do that. It's not a bad idea. I mean, it's a good quick way of doing it, and then you can round up and stuff like that. It's like not a bad idea. And I really do believe, personal belief, and I was a waiter for I've waited tables, if you mash it together, for about 5 years, I'd say. I really think you should vary your tip based on the level of service. Like if you have a really great waiter or waitress, give them a really great tip. If you have a bad one, give them an okay tip. And you never know, like maybe if you hear a loud crash in the back and all of a sudden you don't see your waiter or waitress as much, maybe something fell and they're helping out. That happens. A lot of crashing in the kitchen. So let's see if this is working. I added a lot to it. Find tip. So someone's bill is $30, their tax is $6, their percent is 20%, and we don't have to enter anything else. Percent should be a number. Ooh. So I ran into this error right here. Class percent. What is this returning? Class of this object. Numeric. Did I misspell numeric? What did I do? Percent should be a number. It's mad about that. Class percent should be 20. Well, no, and it'll be, maybe it'll accept it with that. See, it's running into my stop wait. Oh, ha ha, ha 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 ha. Ha ha. Oh. What am I going to put around this? What am I going to put? Because it is contained in there. I could throw it inside of an else, but I'm just going to go here and do this. If it's not contained in there, because right now that's returning true. Because does everyone understand that my function was saying it is contained in there, but I want if it's not contained in there? Does that make sense? So right now my function was evaluating that it is contained in there, but I want that it's not contained in there. Does that make sense to everybody why I just threw an exclamation around that? I see a lot of curly brackets. Wait, there's so many curly brackets on the screen. My function was saying it is contained in there, but I want if it's not contained. And there we have that. Let's double check this. Okay, it's working. And then we go here to pre-tax equals false, and that changes the tip. Does this make sense right here that my function is working 100%? And I think we have one last thing to do. Or did we do it all? I feel like there's one last thing to do with this function. That's got that. Did we just do it all? I swear there's one last thing. But we did some extra stuff right here. Like you're not required to do this right here. You're not required to do this where you stop the function if someone puts in a negative number. So you cannot put in negative percentages. But understanding the differences with stops and warnings. Like we could put warning. And this will do a warning. And we could say like, did you really mean a negative tip? So you could do this right here, and did you really mean a negative tip? Or you could do this. You could go right here and not give a warning, and if someone puts in a negative number, you could go to percent and do what to it? 100-point question. What could you do to percent? If someone takes and puts in a negative number, there's two ways to fix it, but probably a more logical way to fix it. If someone puts in a negative number, what could you do to percent? And technically, yeah, ABS. And what we need to do is we need to do this first because we're going to first evaluate if it's negative, and then we'll convert it. So you have to, this is the fun part of coding, and I really mean it, is trying to break your function. And now if someone puts in a negative number, it doesn't matter. It's not going to stop the function or return an error. It just takes the absolute value of it and overwrites what they put in. So if you look at this, if someone gives a negative number less than 0,
someone's going to do this. And I guess technically to lower computing power, we could stop the function there. The first thing it's going to do is look to see if it's a numeric number. So that would stop the function right on there. Like, did I not say pre-tax equals false? Oh yeah. Yeah, this, it's saved as default as true. Anisha, expand upon that. Did I miss something? So this right here is tipping on the post-tax because we're not tipping on the pre-tax amount. So this right here is where we're doing that computation, that if pre-tax is true, and you can just literally put here pre-tax because pre-tax will either be true or false. So this object right here is the object either true, or we can change it to false by going here. Initially left arrow false into pre-tax. Yeah, and this will do it right here. So we don't use a left arrow right here when we're doing, I think it will work with a left arrow. I just don't like doing that. It does work. I don't like the notation there. I like doing this as setting it equal for that. So I usually don't left arrow when I do arguments. That's where I reserve my equals for. I reserve equals for arguments. Like I don't left arrow into things. And I think that might be an update. I swear it used to not work. But this is where we're doing the calculation here. Does that make sense, Anisha? Beginning of the code. Oh, we wouldn't want in our code to set it equal to anything because we're going to put, oh, is it supposed to be false? No, pre-tax is equal to true by default. Unused argument 0.2. Make sure you have the 4 arguments right here. Make sure you have the 4 arguments. So you must have bill, tax, and then there must not be other things after that. So if you get unused argument, then you must have bill, comma something. Yeah, good questions. Great. 100 points, Sarah and Anisha. Following along, practicing. You have to just go through these examples. I remember the first time I tried doing these activities, I was like, oh my gosh. And now I know how to and I try to think up new things when I do them. I try to I try to be like, how could we fix this? And then when you see errors, like getting better used to what the errors mean. But I think that does it. We need to find the tips here. Let's see. I think I entered in everything we're supposed to do. So we'll see if it works. 4.2, 4.2, 4.37, 4.37, 9.57, 14.36. Got more decimals. That's fine. 17.3. Hey, we got it. We did it. We got it. And then let's look at the answer right here. The answer is going to be set seed, find tip. Let's go over here. Let's find that tip. And 9.92. Is that the answer? 9.92. It is. 9.92, rounded. Does it have a margin of error on it that we can do? Margin of error, 0.01. Need to make sure to leave these margins of errors in. There we go. Let's see right here. Logistic map. Once working your function, the evolve. This is a pretty big one right here. Let's see. Based on aggregate, number 28. I might right here, because I want us to do some clustering activity. So I think, do you guys and gals feel a little bit better about functions? How do people feel like their function skills are on a scale of 1 to 10? Like 1, you have no idea what a function is. 10 being like, I'm not even a 10. I'd put mine at like a 8.5. I'm afraid to say 9. I'd say my function skills are at an 8.9, maybe a 9. I mean, 10 would be like, you can write any function anytime. Like 8.5 is like, I feel confident and I can do 5. 5's good. 6.5 is good. Yeah. 8, ooh, nin. Nice job, nin. So, keep practicing, keep writing your functions. Let's give away the last 2 answers right here because we're going to hop over to clustering now. So once again, the answer key is posted, but the answer to the next one is this. Will it appear? Whoops, didn't appear. The answer to the next one is this right here. Really? I'll just type it out. The answer to the next one is this right here. That's the answer to the next one, and the answer to the next one is... So the next one is PUC. Capital or lowercase? Capital or lowercase doesn't matter. PUC. Make sure that any changes I made to this are saved in the update. But all the answers are out there for Analytics Lab 3. Can anyone say, hey, I got 100? Did anyone get 100 yet on this? Don't we need to round in the function since it wants the nearest percent? Oh, does it? Sure. No, it's returning this right here. It's returning to 2 decimals. So... this you round to 9.92. Got 100. That's what I want to see. And that's the point of it right here. I want you guys and gals to get hundreds if you're following along. That's the whole point of these, is to follow along, practice. You're here, you get 100. That's the way activities work. You're here, you get 100. So that's what I want to see. Remember, the answers are right here for the next ones. Please pause the video or whatever you need. Write these down. These are the next 2 answers. Once again, the answer key is posted. It's not about finding the answers, it's about practicing. Like, you can just have the answers. Like, someone can just say, hey, here's the answers to the activity. I mean, don't really do that for people, but it's about the practice. You literally just have to struggle with code. Who here has coded a good bit before this class, before 320, before 474? And just like, I know some people have. And let's start loading up this next activity here. And what I want to point out, which I'm sure they'll agree with, you literally have to struggle with code. You have to code, you have to struggle with it, you have to just get stuck on it, and you have to be like, you have to put it down for a while. You have to like be like, I'm just not dealing with this code. I'm just gonna not look at it for a little bit here. And I know that sounds crazy. Like, wait a minute, you're saying you have to like stop coding? Yeah, you have to. When you code a whole bunch, your code just won't work. I had to with probs and stats. It was not fun. A bit of HTML, CSS, if that counts, yeah. And not me. A bit in survival analysis class last fall, yeah. And the more you code, the better you get at it. It's literally just practice. Used to be computer science? Oh, cool, Scott. Oh man, you must really know this stuff. Computer science people will tell me things about the coding that I don't know, and that's how I've learned a lot, like with double decimal precision. Do you know a good bit about like double decimal precision? And like R uses array index equal to 1. It doesn't use index is equal to 0. A lot of programming languages will index at 0, but R indexes at 1. And I've learned these things by people pointing these things out to me, and because I'm not a CS major, so but CS majors will know this, like oh yeah, things index at 0 instead of 1. Where C++ is going to index at 0, I believe, and R indexes at 1. And then the big thing about computer science is writing your code, not just that it works, but it works efficiently. Like, you don't want code that works, you want code that runs efficiently and quickly and compiles well. So, like, I hear that's how people are graded. I've never been a CS major. They are the pinnacle of understanding what coding is doing and the computer's doing, because they're computer science. That's the literal point of their major. But we are people who use code to our advantage. We're the people who try to use it in the business world. Not putting down a CS major at all, but they're more like data engineers, or they're more the technical aspects, and we're the utilization. So here we go. Let's get this next activity started right here. Install packages robust base. Is that? There it is. Library. Do I have library mass? I do have library mass. Do I have robust base? I got robust base. And so we have convert categorical. That's going to convert all those categoricals. Suggest transformations. That's such a cool function. We'll look at suggest. I like this for sure. Awesome. Because I feel like this is, and I've had some computer science majors who've taken my class. One guy was like, I finally understand what these algorithms are doing. And not saying computer science isn't teaching him that, but he just said, he came up to me after, it was last summer literally, and he was really quiet in class. And he came up to me and he was like, thank you. I feel like after you've gone through these topics, I actually know what the algorithms are doing and understand the point of this. And I was like, wow, that was a huge compliment. I still remember when he was walking up, I was like, what's he going to say? Like, this class was a waste of my time. No, I really believe in what we teach, because we're not just saying, run this code, do this. It's like, why do we do this? What's the point of this? What's this code finding out? So we focus in on the interpretation and the understanding of the code, not the, just run this code to get this answer. Not saying CS does that, but yeah. Input if you're in class, question 1C requires nulling out the 2 columns mentioned in 1A. Okay, so we've got to null out some columns. We've got to do some k-means, cool stuff. And this is the last topic on the test right here. So wholesale.csv. So what are we going to do? We're going to read.csv, which I don't think we have in here yet, but there it is. So we've got read.csv. We're not in our right working directory because we can't find it. Choose directory, go to the downloads where we store everything, at least on this computer. Go to open, rerun the code down here, and now it's read in. So make sure this is read in. This is a common, this file should be under, do you see it, Anisha? It should be under the details. When you go to the details, you should see wholesale.csv. Can anyone else confirm that this file is there? Can anyone else confirm this file is there? Get some confirmations that this file is under Analytics Lab 4 submission. Yes, it's there. Good. Yep. So that's where the file is found right there, wholesale.csv. And that is the products. We got it right there. Good stuff. Good stuff. Let's start doing some clustering. Let's start talking about reviewing clustering. And the whole point today is I want us to review, like we reviewed the ideas of functions and what they do and the point of them, which is on the test. So this is meant to be a review and activity day today. So we're reading in wholesale, and then it said we needed to null out some columns. Okay, this is going to, we're going to copy it. Cool. And then we're going to do transformations. Okay. So, oh yeah, you have to do all the transformations on this. Okay. So with this right here, hopefully I don't make a mistake this time. So we are going to look at the shape of the histogram. This is the first, oof, that is skewed. Here, I'll disappear. This is crazy skewed. That is ridiculous data. Now, what's the point of a oof? What is the point of a transformation? If I put those sound effects in, they're gonna get mad. What's the point of a transformation? This suggests the transformation. What's the point of a transformation? What's the point of a transformation? What's the point of a transformation? Basically, yep, to make it look normal. Transforming to get normality, that's a big thing we should know. And now we can look at this right here. We don't want to scale the data frame yet. We have to go through and do all the transformations. Let's go to histogram of data processed. And how many? There's 8 variables. That's not so horrible. I mean, you really can't fix this variable. It's unfixable. Sorry, variable. Let's go here, and there's got to be a way to for loop it. I could probably edit Dr. Peach's code. I'll worry about that another time. It would take longer to do. Variable 2, log 10, so we don't need to change anything. So here's the histogram. That's after we've log 10'd it. And so we're going to log 10 this one. Does everyone understand? I'm going to go and I'm going to do what variable next? What variable am I going to do next? What variable am I going to do next after I just did the second variable in the data frame? I'm literally going through and I just did the second variable right here, which was region, which that explains why it's integer values. So now I'm going to go through and do which variable next. You can see it, but it's the what variable because I'm doing the data frame. I'm going through the columns in the data frame. That's what this is doing. The third, I'm doing suggest transformations for only the third column. The vector of information it's taking, do you see the values right there? Those are the values we're seeing. So we're doing the third variable in the data frame. We're asking what transformations should we use. It says log 10. Cool. Change this right here. And we're just algorithmically going through. And as long as I run them all, just be careful to not like double run stuff. Let's go to the fourth variable in the data frame. Let's run it. Let's it says log 10. Everything's gonna be logged. Log 10 is just very popular. It's the everyone loves log 10. It's log, it's big, it's heavy, it's wood. It's log. Wait, oh, it is log. It's better than bad, it's good. Am I the only one who knows that? Am I the only one in class who knows that? Someone, 100 points, who knows what I'm talking about? It's log. And store that. We're just writing the log of the variable into our data processed. And never heard that. Oh no, I'm old. It's official, Brian's old. Not a single person. Official Brian is old. He's a boomer. Alright, it's log. It's Ren and Stimpy. This is Ren and Stimpy from the 90s. You know, back 30 years ago, the 1990s. You are a millennial? You are? That's awesome. I'm a millennial too. Would it be more effective to use a for loop with a vector? Yeah, you could. You know what you could do? I bet we could. You know what we could do? Watch this. We could do apply and array would be whole. And we want to do it to the columns. Suggest. We should be able to do this. Yeah. Ooh. Oh, there. Yeah, it is. We could have done this. This is a much better way. Who said that? Jordan. 100 points, Jordan. So if you look, I just applied the function to all the columns. So this is in tonight's homework assignment where it asks you for the mins and the maxes. So this is a hint for tonight's homework assignment. You can just put here like min, and you can get the min of all the columns like that, or you can put here max. That's literally how to do this one very quickly to get the mins and the maxes. Or you could do suggest transformations So it was a much quicker way than going through and doing what I did. And then I could just take these and take this right here. And then I could probably, well, I want to then take the log 10 of, what's the log 10 of everything? So there's a quicker way of that. So we've now data processed it. We're now going to scale our data frame. And good, those are all 0. And we're going to make sure these are all standard deviations. And we are getting the values, sanity check for the 15th. Okay, so let's look at the 15th for the sanity check. Give me sanity check. Dun, dun, dun. Is it not right? I don't think it's right. Oh, wait, fresh. Fresh is, yes, it is right. There's the fresh right there. Okay, it looks like we've done it. And the milk is that. Everything looks to be accurate. Why doesn't, oh, I think you're supposed to null some stuff out right here. So where does it say we're supposed to null out certain things? And remember, the key is posted. Did it not say we're supposed to null out? Okay. Read in the data frame and null out channel and region. Okay, because those are integer variables. Could you explain suggest transformation? Yeah. So suggest transformation is a really cool function. Suggest transformation goes through and it looks at going from up to 3 by 0.5 different possible transformations to achieve normality on this histogram. I think this is the transformed one. So the whole point of it is to take like the whole, let's do a histogram of whole right here. Histogram of data, what was it, whole what? Sorry, I gotta see what the variable was. Whole, show me the variable. Whole of the 8th, what is the 8th? Delicacy. So we wanna go here to whole, $, there we go. Okay, so here's the original data. So here's the, does this make sense, Anisha? Here is the data prior to a transformation. Here's the data before we transform it. I've been vanished for a while. Here's the data prior to transforming it. And here's the data after transforming it. So what is the whole goal? And I'll explain how this function works in a second. But what's the whole goal of the find transformation function? Remember, here's our data before transformation. Here's our data after transformation. What's the whole goal of it? What is the goal of it? Why do we do find transformation? And then we'll talk about how it works in a second. Why do we do find transformation? To normalize right there, to normalize. Yep. And then why do we do scale data frame? Scale data frame is to put everything to a 0-1 scale. So the scale data frame function is going to take your whole data frame, and it's really good, just does it in a way that it scales everything, and it does it whether it's numeric or integer, and it makes sure it only scales the numeric and the integers. So scale data frame will put everything to a 0-1 scale. It'll only do log 10. If you look at the function, let's go to it. Log 10 is only returned, where is it in here? Yes. If the transformation it chooses is 0, then it'll tell you to do log 10. And if you look over here, we do see, because, where is it? So skewness, because it should do if it's 0. Add 0, okay, function takes x, which is your data, takes the powers from a sequence of this, and adds this right here. Okay, that's an offset. And this right here, require robust base, add this, not equal to this, then do this. Min of this, message equal true, that's fine. Powers, skewness, p and powers. For p and powers, yes. And then there should be the else. Is there an else on here? Return if best p equals 0, then do this right here. So if it can't find anything, I think it suggests log 10, else return this. Which, if it raises it to the 0 power, so I think it's basically saying there's really no good transformation via powers. It's going to do, and so I'm surprised it does it this way. I think Dr. Petrie would recode it now because this is a Dr. Petrie function where it says packages and search for it, download there. How do I download? Yeah. Yep. Not imported. 2 seconds. Let me write this in here for you. So it looks like the log 10 is suggested if it really can't find anything. When it can't find a good transformation via a power, because its goal right here in the function is to look from 0 to 1 going by 0.5 for powers to raise it to. So if it can't find a good power to raise it to, it'll tell you to log 10 it. So log 10 is the one it chooses, and it's trying to find the best, the one that reduces the skewness. So it's trying to find the skewness and try to find the smallest skewness right here. So which powers equals p. So the whole goal right here, best one right here with the min skewness. So the whole goal right here, and it'll log 10 it for 0. Yep. So when it runs 0, it does the log 10, and then it evaluates the skewness at all the transformations, and it tries to find the minimum skewness. So skewness right here, empowers, it goes to the positions of power with the min skewness. I think I just realized something, and I'm going to have to tell Petrie this. Skewness is a measure with 0 being the minimum skewness. But, and skewness I think is in robust base. I think that's why we need robust base. So skewness, you can load skew. Oh. Let me load robust base if it's not loaded. Robust base, skewness. No, it's skewness. Oh, skewness is right here as a sequence of this. Rep, maybe he took the absolute value of it already. Which powers, I'll assume it's right and not critique the function anymore. But he's trying to take the one with the minimum skewness, but there should be like an ABS in here, I would think, where you take the absolute value of the skewness. Rep right here, skewness stored into the transformation, the MC. Where's MC, a function MC? MC right there, and I have to look at what MC does. So med, robust, measure of skewness. It's a robust measure of skewness. Okay, cool. Okay, so all this function is trying to do is it's trying to find the minimum skewness, and skewness is not a function. Skewness is an object being saved. I know we just went through a lot, but does everyone feel like they have a decent understanding, and this was really important theory, of what we're doing right here? We're trying to find a transformation that minimizes the skewness. So the whole goal of the find transformation right here, suggest transformations, is this right here. You can look down here to the end of it, is to find the power that gives you the smallest amount of skew. Just go to this. The whole return right here, if we look at what it's going to return either the best P, and if it's equal to 0, it's going to say log 10. So when it does log 10, it's actually going to do the transformation, or when it does 0, it's going to do the log 10 transformation, else it's going to do a transformation on raising x to the power of whatever it is. And then it's going to return to us, if it chooses 0, which it would have ran log 10 on here, it's going to return log 10, but if it finds a better one, it's going to return this right here. And the whole point of this is to find the power, because this is the one that has the minimum skewness, the position of the power that has the minimum skewness. The position, because here's positions, of the power that has the minimum skewness. And that's the whole point, is to find this, the best power to raise it to. So just suggest transformation finds the best power, and like hopefully if you read through this function, it makes a little bit of sense right here. We didn't talk about what an offset is. Just lets you shift the distribution by a certain amount. That's an offset. And all that good stuff. Really good questions. We're supposed to null out channel and region. So let's null those out. So I'm going to go here to the check. So data, $, was it data processed? Oops. Data processed, $ channel, null. This is how we delete it. And then data, $ region. Remember, the answers are posted, but it's good practice to do this. And then we get the exact answer key right here. Very important that you're getting the same things. If you're not, could cause problems. Make the elbow plot to see if there's any natural structure that exists. So once again, we have these sorts of codes already posted for us. And here's something important, and we've covered this a lot. What does max iterations do? Max iterations is we pick random starting points, and then we move the points to where the cluster centers are at, then we reassign, and then we move the points to where the cluster centers are at, then we reassign. These are the iterations as I move the points. And then we get to end start because we restart the algorithm again, choosing random starting points and reassign the clusters, reassign the clusters, keep moving and reassigning the clusters. And what could we reach if we don't hit max iterations? What will we hit if we don't get to max iterations? We'll have hit what? 100-point question. We'll have hit what if we don't get to max iterations? If we don't get to max iterations, we will have hit what? I'm going to grab the code right here for the elbow plot. So let's go grab convergence. Yes, 100 points initial right there. We'll hit convergence. Yep. And convergence means you didn't have to keep moving the points. You got to it. And good answers right there. Great job. 100 points everyone answering right there. I like everyone following along, practicing. And I'm going to go into the notes because it's the easiest way to get the answers. And we're going to run the k-means algorithm by going to the notes. Easiest way. Where is it? Cluster, cluster, cluster. Where are you at? Cluster. Here we are. And let's go here. We can Google k-mean and we can open it up. And we, nothing? Nothing? Was it k-means? It's k-means. There we go. We don't want those. We want this right here. Okay, cool. And so this is the code right here for I impossible. No, it's not the k-means, is it? Yeah, it's going to be the elbow plot, right? That's going to get elbow plot. Ay, grab the whole code. Grab the whole code, take the whole code, drop the whole code in. It wants that we want 25 max iterations. Why are you being so odd today, R? So max iterations 25. Did this have default end start? There we go. And end start is 50. I don't know why I'm copying 50. It's not like I can't write 50. And then we're saving it. And let's run this. And I think we should. Oh, wait. I guess the toy data frame was in there. We want our data. Is it scaled? What did we call that data? Data processed. And that should do it. And that gets us our elbow plot. Cool. Oof. That's quite the elbow plot. So this elbow plot right here, is this an ideal elbow plot? Is this an ideal elbow plot? I'm going to drop some answers for tonight's assignment. Is this an ideal elbow plot, yes or no? What's a good elbow? Is this, can't do it that way. Is this a good elbow or is this a good elbow? What's the good elbow? Which one's the good elbow? Not really. You want an elbow like this. So this is bad elbow? So far away. Good. So you want a sharp elbow. Bendy. 100 points are there, Adam, making me laugh. So bend it, have a sharp elbow. And you could, let's change this. We got 10 numbers. So I'm going to call this good. This literally gives away the answer. Let's go here 1,000. Let's go to 800. I'm going to go sharper than that. 500, 400, 350, 330. How many numbers? 5, 6, 7, 8, 9, 10. Oh, no, good in here. There we go. This is a much better elbow. That's a way better elbow. What can you say your funny bone? So this is a way better elbow because it has a sharp. If you notice, I just stored a vector of like good possible. That literally gives away the answer for tonight's assignment, which we like to do during class. So this is a really good elbow plot right here. This is an excellent elbow plot. And you'll notice it has this sharp decline right here, this sharp pattern right here. And so we want to see that. What can an elbow plot not do? Elbow plot can't do this. This is an impossible elbow plot. So we're talking about a little bit of theory right here. This is an impossible elbow plot because within increasing the possible clusters you can use could not possibly increase the within cluster sums of squares. Because if you put more cluster centers, things would be closer to their cluster centers. So you can't see an increase to the within cluster sums of squares when you increase the possible k. So let's review. Not so ideal elbow plot. It's like, and it doesn't have a sharp enough elbow. Ideal elbow plot, sharp elbow right here. Impossible elbow plot right here. This is an impossible, can't happen because you can't increase right here. You can't increase the within cluster sums of squares right here. And it says good over there, but we could change it to say within cluster sums of squares, just so I can show it with the thing that I want on the side. So this is the within cluster sums of squares over here, and this is impossible. Can't happen. This is not, no, bad. And so what we can do now, we actually have, and we've got 12 minutes. I'm going to give away the answers to the quiz, so please stay the whole time. The answers will be given away. But what we can do is we can actually use, once again, the notes. The notes are amazing on this, because we can just go here, and we can take the code. Once again, I always want to point to your notes are your best friend, because when you look at this right here, we've got k-means. We're using the 4 clusters, and let's go a little bit further. Here we are with the k-means, with the data set. We have centers of clusters 4, and we're going to figure out where these cluster centers are, and then we're going to take the cluster centers, and we're adding them into the cluster. So that's just going to give us the clusters.
and we can add those as IDs, it looks like. Okay, good. Iris scaled, that's fine. We don't need to use the iris data frame. We're just going to take this code right here, and this should give us the cluster IDs. So let's hop back to this code right here. Our data had a structure. This is our data. So what do we do when we make clusters? We probably would look at like 4 or 5. It's really hard to say. It's in this region. It's like 4, 5, 6. You could start at 3. It's definitely not 1, 2. It's like 3 to 6 clusters because 10's way too many. You don't want 10 marketing schemes right there. So we're going to go to the k-means algorithm. We're going to take our data, and we're going to go to 4 centers. And so when we run the k-mean algorithm right here, we get output from it. So the k-means algorithm, where did it put the output? Where did you put the output k-means? Oh, there it is. It's just so long it wrapped around it, stored into clusters. So here we are. So it's stored into clusters. And then here's the cluster centers. Oh, well, thank you. Well, that's awesome. So these are the centers of the clusters right here with our scaled data. Now we should be able to go to cluster and go to cluster, which gives us the cluster numbers. So you know what we can do is we can go to our data processed. You know what I'm actually going to do? I'm going to take this and store this to the whole data set and call this K4. So why am I calling this K4? Because there's 4 cluster centers. And then I go here. I'm going to store that as K3. And I'm going to store this as K5. And let's store this as K6. I'm also going to do it in the data processed. Let's store. Oh, did I just overwrite that, everybody? I think I did. Please tell me if I make a mistake. I went too quickly on that. Yeah, I did. I think I just did. So, oh no. So my cluster center 4s are wrong. And my cluster center 6s. I'm about to do it again. Okay. So what am I doing? I'm writing, let me do it 3. And so this will be K3. I'm just storing to these data frames, and I'll show you what's here in a moment. It's just algorithmic work right here. Just don't make mistakes. We'll be able to see if we made a mistake on it. And don't make a mistake. Okay, so let's take a look. Good, that is correct. In the data processed, you can see data process doesn't have K4. Oh, what did I do? Probably going to be on the end of it now. Yeah, it is. And the whole food doesn't have... What have I done to my data, everybody? Whole should have 3. We're literally going to rewrite these because I'm waking up. It should have 4. I want to make sure they're right. And it should have 5. Don't hit the button. And it should have 6. Okay, so let's take a look. Data process has 3, 4, 5. Okay, data processed has, okay. Got it. K4, K6, K3, K5. It looks to be accurate. Okay. So now that we've done this, we can look at right now our data. Let's go to the aggregate and let's aggregate data processed right here. And we are going to do dot tilde K4 comma data equals, my computer's being so odd today, this comma fun equals, and let's go to mean. Work today? Got it. Okay, good. And this is 4 clusters. Awesome. Okay. So what do we have on the screen right now? Everything on the screen, very important. You need to know this instantaneously. Everything on the screen is what right now? Everything on the screens is what's. Everything on the screens is what's. We've got 6 minutes or so. We totally have this. Everything on the screens is what's right now. They are the means, but since they're z-scores, yep, these are all z-scores, because this is the data process which has been put to 0s and 1s. So the things that should jump out to me immediately
Everything right here has negative z-scores. So people in cluster 3, and we could see how many there are in this. We could see how many groups there are. So if we go to table, data processed, $K4, there's group 3 has 43 individuals in it. So we can see how many people there are in each of these groups. And this is our low buyer group. Don't worry about these because these are just, those don't matter because they're the different groups. Right here we see these are our average customers. See, I'm not even thinking that a 4 data scheme is good on this. I might go back to a 3. I want to look at the 3 real quick. And now we're seeing the z-scores for this right here. Let me make that even bigger. There we go. So here's the z-scores for this. You've kind of got your above average buyers. You've got your average-ish. And these people, man, the clustering scheme is just really not good for this. So you could then switch this, and this is what I like. If I just switch this over to Whole Foods, I can look at the means for these people. So here's the mean of what people are buying, and the channel and region don't really matter. But you can see the means for these groups or the medians for these groups. So this is the data back in context here. So you can look at the means or the medians for each of these groups, and this is why I made all this output right here, so we could go between these groups and try to see if there's differences. But once again, and I want to point to one last thing right here, I'm going to switch methods on this because the other way of clustering that we learned is dendrograms, which you should understand very, very well. When we go to the dendrogram, we're just going to take right here. Let's take, and it's going to be H cluster, hierarchical clustering. And right here, we're just going to go and take our data, and let's go ahead and take it. And we should get this. It's just so easy. The codes are right there. We're going to need to expand this plot, and let's see right here. Computer is just being so odd today. Hierarchical clustering, data single, and we have it right here. And let's go ahead, and we don't have data. We have data processed. And here we are. Oof. Oof. Wow, no wonder. Wow. Complete. Okay, that looks way better. Okay, cool. I'm good. I'm happy. Very happy. We got 3 minutes. Brian's going to go for a cluster scheme of what right now? What cluster scheme am I going to go for? Who knows the answer? 100 points, first person. Who knows that answer? What cluster scheme does this just scream to me? What cluster scheme does this scream to me? 2. Yeah, this you could try something like Ward's D on this. You could try, but that looks like 2 to me because why is it 2? There's really good separation in here between this area. I'm looking at this area right here and being like, there's a really good kind of a 2 cluster scheme. So we're going to do cut tree and cut tree 2. So we should have the cut tree. Where's my cut tree at? Cut tree. And you just do K2. I mean, I was like, I'm afraid I'm going to get that code wrong. It's just cut tree, and then you say how many K you want. Now that assigns the ID. So we're going to take the ID, and we're going to go to the data processed. And we're going to go to data process. Let's go here, $K2 from hierarchical clustering, and store that into here. So that stands for K2 from the hierarchical clustering. And then we're going to do the same thing, but we're going to go here to whole food. So now we're going to go to the whole and do that. We're going to grab our aggregate, and we're going to look at it right here with the K2 hierarchical clustering. And we're going to do first the data processed. Processed. We have 2 minutes. So, you know what I might do? What's the easiest way to give everyone hundreds? Is this a good clustering scheme? Man, this data set just doesn't work itself to clustering. That's the problem, is sometimes there's just no good answer. If we look at this right here, the data, what's the easiest way to give everyone hundreds for today's activity? What's the easiest way to give everyone hundreds for today's activity? Anyone got some suggestions? For the second one. No, let me change the quiz around. Let me change the quiz. That's the easiest way to do it. Let me change the quiz. Why not 100 for the class? So let me change the quiz around, and that'll be the easiest way to do it. We did some really good examples right here, and we did a lot of coding. So let me change how the quiz works. Okay, so stay here for another 30 seconds if you can, or 1 minute more likely, and I'll explain what's going on with the quiz now. The only question that's worth points on the quiz is the word you hear. I'm going to say, like, did you watch today's lecture as the first question? So I'm updating the quiz right now. This is the right question. So every question on the quiz is worth 0 except the first question. So the first question says type 1 if you watched class today, if you watched the clustering activity. Type 1 if you watched the clustering activity worth 10 points, and update the quiz. Okay, good. So all you have to do is say you watched the activity, which is kind of an honor system thing. I don't want to put all the answers in the chat. But does that make sense to everybody? If you watched it, just put 1 in there and you will get 100. We talked through dendrograms a little bit here. I wanted to use today to review. So for lab 4, this is lab 4, and then lab 5 we'll be doing probably tomorrow a good bit. Lab 5 we'll be doing tomorrow, which is not on the test. Lab 5 is not on the test. So lab 4 you will see is on the test. Lab 4. Yep. So today was like mainly a lab day where we worked through a bunch of code and we talked through the examples. So all you have to do is put in a 1. If you're watching this, who has 100 on that one also now? That's my goal, is if you're in class and we just ended 1 minute ago. Sorry, thank you for the extra 1 minute. We try to start on time, we try to end on time. Yep. So once again, these are meant to be things that if you're here, you get the hundreds. That's the goal. I don't want it to be like, wait a minute, this class, like, hey, we got 20 activities and it's going to take forever. We're here to code, we're here to practice, and that's what we do. So good stuff. If you were following along today and you were coding, you were learning. Oh, sorry, Adam. Yeah, I updated it. Yeah. So I'm so sorry, Adam. And then the answer keys are posted to these. So you can, this is a different activity for 320. But that's got it. Who has questions about the assignments? This is all the clustering stuff right here. It just goes through different clustering examples. But feel free to ask any questions you have about the assignments or the test. We will be doing Kahoot at 2. Kahoot at 2. So I'll set up the Kahoot and have it running later. So who has questions? If you have questions about the assignment or the test, feel free to ask right now. Who has questions? We are done. We have like 2.5 weeks. Let me look at the assignment pace for us. Make sure we're on good pace. I think I'm more worried about 320's pace. It's so weird. I hear like... Yeah, I hear like a radio signal through my headphones. I swear it must be... I wonder if it's picking up on like an FM signal or something. But I hear the faintest... Hear that I'm hearing voices in my head. Because I know I'm hearing something. I'm like, I am hearing something. Clustering is due tonight. Association rules is due on the 20th. That's more. We're already through association rules. So that's perfectly fine. And then concepts in predictive analytics is due on the 22nd. So we'll need to finish that this week. Okay. So we need to make sure we finish concept. Yeah, we have more than enough time. We've got 3 days to finish that. Vanilla regression is the 25th. We're fine on that. Tree-based vanilla and regularized models. Tree-based models on the 28th. So next week we need to do those 2 topics. And support vector machines and neural nets are probably going to be a bonus. So support vector machines and neural nets probably going to be a bonus. Did everyone hear that? If you're still here, support vector machines and neural nets probably going to be a bonus. Yep, I'm here right now. 3D for which one? Could you go over how to do number 3, hierarchical clustering? I've looked through my notes, can't figure it out. Yep. Question 3, let's do it. This is homework. Here, sorry the numbers got a little bit off on those. It is office hours. We're doing some little hierarchical clustering right now. And hopefully this is not the one that drove me mad yesterday. So Q3. Okay, here we go. Is this the one right here? Is this the one? And then Ryan, we'll go back and do that. You got it, Ryan. Chunk 14. Chunk 4. Oh. Okay, yeah. Okay, cool. This is a good one to do. This is a great one. Okay, so with this one right here, and this basically drops the answer for everybody, which is really good. Could you go over a bonus for assignment 5? Yeah, Alexa. I think I'll do that next, Alexa, because I'll show you something really cool with that. So Alexa, that one's next, and then we'll do Ryan's, because I really want to show something off there. Okay, so this right here could very well be on the test. And the question right here, well, what we need to understand with this is that this is the distance 1 is away from 2. So it's like you have a bunch of data points. Let's show a bunch of data points right here. And when you have a bunch of data points, your data points are going to exist with a distance they are away from each other. So we've got here 5 data points, like data point 1, data point 2, data point 3, data point 4, and data point 5. So it'd be 1, 2, 2, 3, 4, and 5. So when you look at this data set right here, and we'll make it a little bit easier to see what's going to happen. Oops. Stop acting weird, computer. Probably it's going to be easier if we do this, and then we do something like, I'll put it here. Okay. So that's 3, and that's 5. Okay. So what 2 points would merge here first? So no matter what, if we do single or complete, we can look at the distances like 3 is from 4, 3 is from 5, 3 is from 2, 3 is from 1. And so we can look at the distance from that. 1 is from 3, 1 is from 4, 1 is from 2, 1 is from 5. So 1 is closest to 2. So that's what you're seeing right here. All of these distances, like 1's distance from 2, if this was, it's not the same graphic, but if it was, 1's distance from 2 right here would be this numeric value. Does everyone understand what this means? It's telling you the distance a certain point is away from another point. Does that make perfect sense? Does everyone understand what this means right now? We're doing all the combinations of this point is this distance from this point, and this point is this distance from this point. Get some yeses in the chat. That makes sense. Cool. So these are the distances, like 1 is from 4, 1 is from 5. So here's a key thing. We always merge on the what. People need to remind me, we always merge on the what. Like this is, you always merge on the this. You always merge on the this. You always merge on the this. We have to know that. You always merge on the this. We have to know that instantaneously. Smallest distance, Vajrana right there, 100 points. You're right. Smallest distance, and Anisha right there, 100 points. These are office hours bonus points. You know what's going on. Office hours time. So you can add these on. So 4 and 5 are going to merge. So I'm going to put this as a 4-5 group right here. And 4 and 5 are going to merge. And since 4 and 5 merged, I'm going to delete this distance from them. I'm also going to go here and call this a 4-5 group. And I'm just kind of recoding this like manually so I can see what's going on here. This is 4-5. Okay, so we're not finished with this yet, but this is the way I like to solve these problems, and I'll show you why. Because now I have choices. So now I'm going to look at the distance that 4 and 5 are away from either 1, 2, or 3. So my goal now is to reduce and remove either this value or this value, this value or this value, this value or this value. Now, the choice here depends on if I use blank or blank. 100 points first person. The choice here depends on if I use blank or blank on which distance to keep in the distance matrices. How come you didn't add the one? Oh, because that's where we merge. We just merged. This is the 4 and 5 merging because this is like they merged. So 4, 5 is now one cluster. What happened right here, and it's close. Let me change the numbers right here. If we were to view what happened visually in this, it would look like this, that 4 and 5 just merged into one cluster. So 4, 5 now became a cluster 4, 5. Does that make sense right there? Vajrana, that 4, 5 has now become the cluster 4, 5. Like 4, 5 is now linked together in one cluster. They have merged together. So they're now the cluster 4, 5. And now we'll evaluate 4, 5's distance from 3, 4, 5's distance from 2, and 4, 5's distance from 1. But we have other ways of measuring it. We have this distance or the red distance. Do you see one of these distances is the one we'll carry over? Does that make sense? Like if you look, there's 6 distances now in here. Here's the 6 distances, and it's either measured from 4's original position or 5's. 4's original position or 5. 4's original positions or 5. So that's where you see these 6 differences being shown right here, where we can calculate the distance 5 is away from the point or 4 is away from the point. And people, who's the first one right here? Caroline, you're right. We need to know if we're using single or complete linkage, because single would say take the what is different distance. Single would say continue with the blankest distance. Single would say use the blankest distance between the clusters now, smallest. Great job, Casey, right there, 100 points. And complete, and we are using, use complete. So we are using complete, which says take the biggest difference. Yes, so there, Vajrana, another 100 points. It does say complete, so we are going to take the biggest distance. So which of these two numbers will carry over? which of these two numbers will carry over? Of these two, the distance 4, 5 is away from 2 will carry, which of those numbers will carry over? Yep. So let's go there. Which of these numbers will carry over here? Not, you can't do that one. Which of these numbers carry over here? What do those numbers carry over? Yep. Which of these numbers carry over? I think you guys see it now. The bigger number carries over because we're using complete. I'm just reducing my matrix size. Okay, now I'm going to trick you. I'm going to say a trick question. We're doing complete linkage. What distance will we merge on? We're doing complete linkage. What distance will we merge on? We're doing complete linkage. What distance will we merge on? This is a trick question. If you're like, but wait a minute, we always do this. Well, then you're doing it right. But since I'm like stressing complete, we're doing complete linkage. What distance will we merge on? Yep. Casey's right. Because we always merge on the smallest distance. Complete and single, that's the trick. That's the trick. The way we carry over the distances and we calculate them is based on single and complete, but we always merge on the what is distance. We always merge on the smallest distance. But the way we calculate the distances depends on single or complete. Like, how do we calculate the distances is single or complete. Like, here's the single linkage between 4, 5, and 3. Here's the complete linkage between 4, 5, and 3. Does that make sense? Like, I'll show you single versus complete. So the way we calculate, that's the single linkage. And then here's the complete linkage. So the single linkage between 4, 5, and 3 is the smallest distance, and the complete linkage is this. Now, that's how we calculate the numbers in the matrix, but once we get the numbers, we always merge on the smallest distance. So we're going to merge together 2, 3. So 2, 3 would merge into one cluster. Let's go ahead and call this cluster 2, 3. Stop acting weird, R. And we're going to call this 2, 3. Now, if you notice, we need to reduce this, and this is now cluster 2, 3 here. And this is cluster 2, 3. And not 3, 3. 2, 3. And let's look at how this works. Okay, I think that's got it. There we go. Okay. So we need to reduce this matrix down. Obviously, this right here can go away. And so this is going to be NA. We can just put NA in there for the moment. It's just, there's no distance 2, 3 is away from 2, 3. That does not exist. Now we need 1's distance from 2, 3. Since we're doing complete, what is 1's distance from 2, 3? Since we're doing complete, what is 1's distance from 2, 3? And so what would be the answer? What is 1's distance from 2, 3? Yep. And be careful. Don't look across this too far because you're just doing 1's distance from this, 1's distance from this. So let's go ahead and put an NA in right here. So I'm going to put an NA because we're just going to remove that out for the moment. If you notice, we can then delete off that column. And then over here, we need 2, 3's distance from 4, 5. What is 2, 3's distance from 4, 5? How far away is 2, 3 from 4, 5? So you need to look at where 2, 3 is from all the 4, 5s. Where's 2, 3 from all the 4, 5s? What is 2, 3's distance from 4, 5? Correct, 9.1. You might be tricked and think it's this, but that's 4, 5's distance from 1. That's, so people didn't get tricked by that. It's going to be this right here. So what are we going to do? We're going to NA out this. And look, this does not have information. If you notice, your matrix is kind of reducing down consistently in size. If you look at the reduction, you're removing like, one row, one column each time, and you're getting this like matrix reduction. And so now we have 2 and 3 have merged and 4 and 5 have merged. And what will merge now? Remember, here's the trick. We're doing complete linkage. We're doing complete linkage. What distance will we merge on? We're doing complete linkage. What distance will we merge? Like, what number merges here? We merge right here. Smallest distance. Always merge on smallest distance. The way the distance is calculated is based on single and complete, but we're going to merge together 1, 2, 3 into one cluster. So 1, 2, 3 merges. And this is actually really easy now because the only number that will continue in the matrix is the what value. So the only number that will continue on here is the largest number, and that'll just be the distance. So, oh, it's 9.7. Good. That's the number up there. It's just going to be this distance right here. We could delete these down a little bit. But it's this number here, and that's the distance of the final merge. Does that make sense right there? Who feels like they understand this a good bit better now? Like, okay, I see how it's merging, and we could do it in single linkage, and we would just carry over the smaller numbers, which would then But the final number is always the biggest one because the biggest one, good, Casey. Yeah, it's good practice. And I'll be writing more of these questions later tonight on this. I finished 320 yesterday midday, and then, whew, whew. I promise you, when it's a big week for you guys, it's a big week for me. And the grader's been doing awesome. I'm so lucky we have the grader we do. Like I was like, I need this grader for the summer, or else I'll go crazy. Because a lot of times I'll do my own grading, but with all the I think, and where was it? Who are you still here? Please tell me so. Yes. So you want us to show the 4 different merges? Yeah, show the 4 different merges. That's the best way right here to show the 4 different merges and to go through the process. I mean, you can kind of say them all, but it's better if you say, like the first merge is 4 merges with 5, then 2, 3 merge, then 1, 2, 3 merge, like 2, 3 merges with 1, and then everything merges into 1. And so the last, once you do this, you could write that out. Everything merges into 1. Yep, we'll do that here next. I think there was a question. Tell me you're still here. Are you still here? Alexa, are you still here? Alexa, let's hear if Alexa's still here. Because I think, Alexa, are you still? Yes. Alexa, are you talking about the bonus with the top 5 correlation? So what I did, and I showed this to 474. I wish I showed it to 320, but I loaded it up between classes to show them. Because this is the top 5 correlation bonus, which I think you're talking about. And this is what I coded in 2016. So in 2016, this took me 2 hours to code. And if you look at what it does, is it goes through, it finds the correlations right here, finds the absolute value of the correlations, orders them, does all of this stuff, and it's finding the top 5 correlations like this. But then I went through and over the weekend decided to just code it, and it took me about 7 or 8 minutes. It was very, very quick. This is my top 5 correlations now, and I don't know, maybe I'll just send it to you, maybe just email and be like, hey, send me that code. But what this code does is you can actually knit it. No, the bonus question on 5. Is that the NFL one? Is that the NFL bonus? Is it the current one? Oh, there is. The GoXLR is picking up on something. That's so weird. Like a radio signal. Oh, I can talk about that one. I'll talk about that one here in a moment. This is the bonus right here. And you notice it does the top 5 correlations. Yeah, here we'll talk about the NFL one. Okay, so the NFL one is a huge glimpse into the future. Let's talk about the bonus on 5 real briefly here. So the NFL one is a big glimpse into the future. We're going to load up library reg class right here. And when we load up library reg class, we need to do EX6 NFL, is it? EX4, EX3. There it is, EX3 NFL. And we want to predict the wins a team will have, I think, next year wins. Is it next year wins? So we want to predict next year's wins. Ooh, there's a bunch of NAs in here. That's interesting. I should look at the data more often. So we want to predict how many wins a team will have next year. We can change it if we want. Now, the easiest thing to do is just to create a simple linear model. And to create a simple linear model, we do M, save into LM. We could predict wins from, we want to predict next year's wins from this year's wins. And so let's go here, and let's go to wins, and go to data, and EX3 NFL. This created a simple linear model. And I don't want to give away this answer completely, but I'm going to show you some cool stuff right here. So with this right here, we now have a simple linear model. And if you notice, this year's wins only explains 8% of the variation in next year's wins. It has a typical miss of about 3 wins. So when we predict next year's win, which I think is in one of your assignments, I think it's in this assignment, we typically miss in predicting, this is an answer to a question in your assignment, we typically miss predicting next year's wins by about 3 wins on average with our model. Our model typically misses predictions of next year's wins by about 3 wins on average. That's what the typical miss is. We only explain 8.5% of the variation in next year's wins using this year's wins, which these are key answers to your homework questions. But here's something crazy. There's a lot more variables. It's so weird. I don't know why I'm hearing things through my head. So there's this model right here, and let me remember how to do this. We need to make 2 models first. We're going to make the naive model, and we saw this in the notes today. The naive model has 1 right there, and we're going to make what's called a full model, and this is why this is a bonus, because I don't expect people to know this. That's right. So weird. And there's the full model. And so here we go. What is the naive model? The naive model is the model that's just the intercept. So here's just the intercept. The full model has how many variables in it? Does anyone remember from 474? And this will be important for our class later on. So if you're 474, this is actually kind of getting into next week's topics. We'll start doing stuff like this again and go deeper into data mining and model building. Like 474 is like the enhanced version of 320 in a lot of ways. Like you have to have if you have your base 320 knowledge, it stacks on top of it. That's why 320 is a prereq for 474. So the full model has how many variables in it? Think about like it being called a full model, or sometimes it's called, you can call it complex. It's very complex, but we'll call it a full model. How many variables will the full model have in it? The full model will have, it's full. So many variables will have in it. All variables. Inisha, great job right there. 100 points, Inisha. Has all your variables. So the full model has all your variables in it. So if you look, we just put in all of those variables. We're even getting some issues with multicollinearity and non-independence of variables where it can't do variable estimates because we're running out of variation. We might even get an R squared of, I thought we'd get higher to 1, but we explained 65% of the variation. But if anyone knows about R squared adjusted, this is not a good model because R squared adjusted is adjusted for how many variables are in the model. And look at the difference between your R squared and your R squared adjusted. The R squared adjusted, this is a hint for the future for 320, is a penalized version of your R squared that penalizes you for the more variables you put in the model. So the more variables you put in, the larger the penalty on R squared adjusted because it's adjusted for how many variables in the model. So it's like a fairer way, hints for the future. R squared adjusted is a much fairer way of assessing how your model is doing than R squared. Because R squared, every time you put a variable in, must do what? 100 points first person. Every time you put a variable in a model, R squared must do this. Technically, it could stay the same. Technically. Like if your X has no variation in it or it does not add new variation. It either stays the same or does this. One time a student said that to me. They're like, well, can't it stay the same? I was like, okay, technically. It's unlikely if the variable is any sort of variation. Who knows? And if it explains variation, which is R squared would do what with a new variable? Initial 100 points, 200 points off 0 points max. If x's explain and we keep adding in x's, R squared would do what if we add in more x's? Since x's explain, and if we add in more variables, R squared would do this. Like the more x's you add in, since they explain, increase, Kelsey, yeah, it'll increase. So R squared is biased to continually go up, but R squared adjusted is the one that can go down. If your variables are bad, R squared adjusted can go down. Does that make sense, 320? That's going to be big in your class. So R squared adjusted is adjusted for how many variables are in the model. If you have bad variables, R squared adjusted can go down. So this one always goes up. This one, if the variables are bad, will go down. It's a much fairer way of assessing your R squared. And if you look, there's a dramatic difference right here. And R squared adjusted is showing you probably have too many variables in your model. So how do we choose the right amount of variables? Well, we've got what's called the step procedure. And so this is a model search procedure, which I think it'll be one of our last topics. So it's a big glimpse into the future. And the model search procedure starts with the model we're starting with. And then we go scope equals list with lower equals naive and upper equals full. I'm just basically doing the problem. And, well, there's more ways to do it. And direction. So equals, and let's go forward. It's working. This is now searching for the best model for me. What it did is it started with no variables in the model. It started with absolutely no variables. And then it looked at all the variables, and we can see its process at one point. So it looked at the variables and it said, what variable can I add to the model? And we'll look at the second to last step right here. So it said, the best choice right here is to add this variable to the model. So it's going to go through algorithmically and look at each variable and say, add this variable to the model, don't add this variable. And eventually it'll choose to make no action. So if you see when it stopped, it said the best choice is to do nothing. So here it said, don't do anything. And then you get to the very end of this and the algorithm stopped. But you know what we could do? We could start with the full model, and instead of going forward, we'd have to go what? If we start with the full model, we'd have to go what? If we start with the full model, we'd have to go what? Not forward. If you start with everything in your model, you'd have to do what? So you start with every single variable in your model, and you'd have to do where? backward. I think it's backwards. Let's find out. Does it like it? Up. Wait. Backward. There we go. Now, if we were to look at one of these processes, which it's just flooding output on the screen. Oh, there's the minuses. It's figuring out what variables to remove from the model. It started with everything in the model, and it's looking and saying, okay, take this one out, 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 this one, this one, this one, this one. It's taking variables out of the model, trying to make a better model. And it's searching, 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 still searching. Oh, nope, still searching. Okay, you know what I did? I forgot to do this. I forgot to store it. So we got to watch the search one more time. Okay, so this is starting with every single variable in the model and then removing the variables that are bad variables. So this is a search procedure where we let it algorithmically go through and try to figure out the best set of variables to include in the model. And this is different from all possible models, which would evaluate all possible models. Now, this is a 474 question. Really great question right here. Oh, I need to write these for the test tonight. It's market basket. It goes on the final. This is a final question. If I have 140 variables, how many ways could I make 10 variable models? What would we do? If we have 140 variables, so choose from 140, choose 10 of them. That's, wow. And it gets even crazier if you go to this. 70 variable models is that. So the problem here is, and this will come up in 320, is if we were to say, let's look at every possible model, we'd be looking at quintillions, Googleplexes of models. We'd be looking at ridiculous amounts of models. So the amount of models we would have to evaluate, if we evaluated every model, would just require computing power we don't have. And so this is just the way in which you could make 70 variable models from 140 variables, which we do have something, if we look at the number of columns in, let's do dim. Hint, yeah, sure. Hint, 474. Why are you acting weird, computer? Yeah, we got about 140 X, 136 X's. So, oh, but then there's categorical variables. That's going to cause problems. More on that later. So when you look at your summary of your model right here, which we've basically solved the bonus, 60%. Let's fix this. I don't like that. 60% is not that amazing. Let's try this. Both allows us to go forwards and backwards. Now, if you notice, you'll have pluses and minuses on here where you can add and subtract. And so I didn't like the 60%. Both is usually better. It just takes more time sometimes. And now we're up to 51%. Let's start with the full model. And let's see what we get with the full going both. So you're welcome, Alexa. And, whoops, I'll wait for that to run. So now we're doing a search procedure trying to figure out the best way. And if it's next year's wins or wins, make sure you're predicting the right variable. And wait, Alexa, one more thing. I got to mention this. Do not put this output in your assignment, or by doing the bonus, you will destroy your bonus. You need to add in one more argument, and this is super important. This is a huge alert. Please, if anyone's doing this right now, please pause the video, and I should stop this code from running, but I really want to see what the result is. Once this code runs, I'm going to show you what you must add in to make sure you don't just crash your, you don't destroy your chance. Yeah, we're still getting so-so. Maybe it was supposed to predict wins, because I swear the bonus is a higher. You enter in trace equals 0. If you enter in trace equals 0, the output does not appear to the screen. Trace shows you the output. Put trace equals 0, and you will not see the output appearing to the screen. So the first argument is the model you're starting with. The second argument is your list of models you're considering. And the third argument is the direction, and there's the scope. So let's put some notes here. Starting model. This is where you're starting with. You either start with the full or the naive, generally speaking. List of models considered. Direction the search goes in. And trace controls output. 1 is yes. 2 is no. Does that make sense there? And make sure to put in trace equals 0, or you could, by doing the bonus, lose the assignment. So, and I think there was a lot more. Where was there was a 474 question next. What was the 474 question? So, are we going to have review for 474 tomorrow in class? We'll do some more review. We'll do a little bit of review, like another 20, 30 minutes of review. Today was the Kahoot is going to go over a lot of the coding stuff tonight. So the Kahoot I'm setting up for 320 and 474 will be in 2 hours, 15 minutes. Chunk 6 and 7, 8, you got it. And so the Kahoot, and I think question 1 is after that for 320. So there's a question 1 for 320. So we'll do that next. Remind me that I said 320 is next, question 1. And I'll probably go to about 12:30 today. So that way I get the Kahoot finalized. Chunk, where's the chunk at? And thank you, everyone. A lot of hard work going on in the class. Chunk 7 and 8. Oh, we got this. We do this. You ready? So here we are with auditioning the clusters right here. Let's try to make the elbow plot using this right here with the max iter. And I think I have it on the screen. So where did I get this code from? And this is the Kroger scaled data frame. Make sure Kroger scaled not found. I think we made this yesterday. So you have to make your Kroger scaled data. Very important. Did we make it? Where's my Kroger scaled? I made it yesterday. Here we go. Did I put it lower? I think I'm not in my right. Let me check. What is not running? Load this. That's the issue. Did I reset my working directory? Set working directory, choose working directory. Well, why did it load yesterday? Stop being weird. BAS 474. There we go. Let's go grab it. I would have no idea how it would load yesterday and not load today. I don't like weird things. And let me go grab it. Clustering. And that's why it wasn't loading. And there we go right there. Let's load it. Cannot BAS. Is it downloading the wrong spot? Session, set working directory, choose working directory. Downloads, open, load. What's going on? It's saying can't find the file, no such file or directory. Oh, we're in stat 201. Downloads. You know what we'll do? I got an idea. I have an idea. Let me go over to here. That's a totally different thing. Everything's haunted, everybody. It's all haunted. Oh, it's called that? Our workspace. Okay. Hopefully no one else is having this. Homework. HWR. It's in downloads. Okay, cool. It's called HWR. This should fix it. Don't know what's going on right here. Don't like when weird things are happening. So, computer is acting so odd today. HWR. There we go. Okay, so now we should have the... What I'm going to do is I'm going to clear this out. And for some reason, hopefully, there's the Kroger. Cool. Let me run everything now, because we should be good on it. It was chunk 6 and 7. Chunk 6 and 7. I'm losing my mind. Here we go. And everything's loading. I think we have everything loaded up from yesterday. And we are good. So now this should work. And haha, Kroger scaled. Really? Did we not? Kroger, we haven't mistyped, I think. Kroger scaled. It's Kroger scaled right here. There we go. There we go. Error. What's the error right here? No such variable. Let's figure what's going on. Sorry, the way coding works sometimes. So that loaded in. That's an error, I think, right there. Oh, wait, it's the 4. There we go. There we go. That's going to do it. Error figure tomorrow. Okay, that's good error. It's not a good error, but I know how to fix that. Cool. Okay. So let's go right here. Let's see what people are saying after that long stretch. There we go. Kroger scaled. You got it. So here is the elbow plot we get right here. And then which question was it that people wanted? Chunk 7 and 8. So I think we're on chunk 7 right now, right? So when you look at this chunk right here, this is in the notes. This is on, let's go ahead and find this in the notes. It's the I in possible K. So let's go to the notes and point out where this is at. It's the I in possible K. So I impossible, and there it is right here. So this looks to be, and I think it's the only, that's just redoing it again with a different data set, right? That's the toy data set. This is the flyer data set. So this right here is, we're doing it 3 times? Cool. I impossible K for the CL data set, and this is the ideal clusters that are 4 clusters, and then the I impossible K for the right here for the toy data set, and you see data that more often looks like this, and you see data that looks like this. Now it's going to say an error again, but which of these is an ideal one? Is it the first one, the second one, or the third one? Which of these is the most ideal? The first one, the second one, or the third one? Which of these is the most ideal? When I uncomment out, you might have to send it to me. You might have to send it to me. I don't see the 4 before that. And Nitin's right, is the first one is the most ideal. The first one's the most, they're all not that bad. Yeah, you must, I don't see the 4 before it, so you need the 4, and then the I impossible K. So you need to make sure to have, grab this whole thing right here, and it says some corrections to make on it. It says like change this to this. Computer is haunted today. So those corrections right there. Send it to me, and we will get it fixed up. We will get it fixed up. So just make sure to grab this off the slide, but then you want to change the data it's working with. I think it has a different max iteration, and it has a different end start. So right here, if you notice, we have an end start of 25, and we have a max iter of 30. Oh, is it? Okay, good. Yeah, if it's not working, just send to me. And the centers are changing for each cluster we do, so we're storing the best within sums of squares based on that, and then we're going to plot it over here. And then, computer's being so weird today. What does the iter max parameter control about this algorithm? Who knows what the iter max controls? The iter max controls, when we run the algorithm, it controls us reassigning the cluster centers based on the random starting points. So, yep, and then expand upon it a little bit more. Good answer so far. The maximum amount of iterations that we can do when we choose random starting point first, which that's not an iteration. You choose a random starting point, and then you assign cluster centers, and then you move the cluster centers. This would be the first iteration. Once you move the cluster centers right here, and then you reassign the points, and then you move the cluster centers, and then you reassign the points, and you move the cluster centers, reassign the points. These are iterations now. And then you restart the algorithm. This is the end start now. You restart the algorithm and choose random starting points. And then you move it. Nitin right here, we were talking about this yesterday too. This is a calculus problem, isn't it? Because you're trying to find the global minimum of a multidimensional space. So it's like a multidimensional space, and you want the global minimum of the within cluster sums of squares. And you could maybe figure this out through like matrix algebra or something, kind of. Yeah, maybe I'm using the wrong terminology. It's like topography stuff and everything. Like if you choose certain spots, you'll kind of slide down into these areas, but there could be like local mins, and then there's some global min that exists. But as soon as you get into this hole, your algorithm will find an answer that might be a local minimum and not the global minimum. And so based on the spots you choose, you'll get different answers. So you have to make sure you restart the algorithm, because the random starting points you pick will lead to certain answers. So very, very key right there. The random starting points you pick, that's why we do the end starts. End starts controls the number of times the algorithm restarts to pick random starting points, which allow us to obtain different answers, which could be the best within cluster sum of squares, i.e. the smallest. Does that make more sense on what these are doing? And I think we've kind of done the ideal elbow plot today. The ideal elbow plot, computer's being so weird today. So, and then here's the ideal elbow plot. We have this inside of here. I'm going to kind of, I did this earlier, so I'm going to kind of be like, hint, 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 look back. I think it was at the very, near the end of class for 474. Go back and look at that and see if you see where I did the ideal elbow plot. Is everyone feeling a good bit better on these? Are people feeling, and I'm going to do in 321 here in a second. Who's feeling a good bit better on these problems? Like, okay, I feel better. I think I got these. These problems look all right to me now. How are we looking on these problems? Good, bad, maybe? I think it was question 1. Are they still here for question 1? Question 1. Ryan, are you still here, Ryan? Question 1 for 320. So was it assignment? Question 1 for 320. Hey, Ryan, how to replace the NAs? Just type them in there. So, homework. Homework 6. Got way too many things open. Go to the NAs and replace them by typing, these are not answers. Don't put these numbers in. Someone's going to put these numbers. I shouldn't do this. Don't put those numbers in. If you do that, that's not going to turn out well. You'll just replace the NAs, and there you go. And good question right there, Caroline. 20 points, Caroline, right there. So don't put in those numbers, though. Don't do that. That'll be wrong answers. Okay, so let's take a look at question 1. Load up reg class right here. Question 1, load the EX6. What do we do to load data that's already pre-loaded in? So I'm going to do this. Oh, it says it right there. We're going to go to reg class because this data is in the reg class library. And we're going to go to EX3 NFL, and that'll load the data. So if you notice here, the data, yep, and it'll load in the data right there. So that's a data frame that's kind of preloaded into R. And now we got to go to the book, which I should still have the book open. Not right now, but file, open, and homework packet. Where is it at? Homework packet. Where's it at? Here it is, homework packet. Cool. And now the homework packet, let's do it. Great job today, everyone. This is the big week. This is the big week. Once we're done with this week, we're coasting to the end. 124. 124. 124. There's 120. Okay, we're on 124. Does it switch sides of the page? Ooh, gotta tell Dr. Petrie that. So 124 right here. Exercise 1. This says right here, use the EX3 NFL data set. Tells us about it. And good, I like it too. Technically predicting the number of wins can range from 0 to 16 is not an easy task, which we can use regression because number of wins is an integer. Ooh, look at this from today. We talked about this yesterday, and this is big right here. Read up on what the normal model and what kind of numbers it describes. Although a more sophisticated model is appropriate, we can still get a good deal about these relationships with the normal model right here. Now, when you think about this, this says that the what's, what are these things right here? These are our what's in the model. These are our what's in the model. These are the what's of the model. These are the what's of the model. Any ideas what those would be of the model? Any ideas what those would be? Those are the what's of the model. Kind of starts with an E. It's like that E word, but it's the actual minus predicted is better described of these. They're the estimates of the true that. What is that E epsilon type thing? These would be the errors. The errors the model make are well described by a normal model. Casey, 100 points guessing right there, or taking, I like it right there. These are the errors the model make are well described. And we have pictures from 320 earlier regarding this. These are the errors. The errors are how far away the points are from the model. So the errors are the misses the model make. And the misses that the model makes are well described by a normal curve with a mean of 0 and a standard deviation that is constant. So the problem we get into with this data is that it's integer based. Like that's highlighted for a reason, or that's italicized for a reason. The data being integer based means that y is going to have a certain structure to it. And since y has a certain structure to it, let's look at that structure of y. So the structure of y right here is going to look like the following. So y is going to have a pattern like this. Because it's integer. It can't take on decimal numbers. So y has to follow this pattern, like wins would not look like this, but y has to be an integer value, which means our line is going to go through the data like this, and there could be multiple points right here. Like this could be a bunch of points, like that right there. Let me highlight it. This right here could be a bunch of points because it's integer based, and I think x is integer based too. And so with this right here, if you look at the residuals at any given point, here's the issue, and this is a very tough problem. It's a tough one to start the assignment. If you were to look at the residuals at any given point, like if you were to take the residuals right here, which our book shows, your residuals would look something like this. And if you notice, we only got 3 points there. But this correlates to this right here, and there's multiple points. We're saying there's multiple points on that observation. And this correlates to this. Now, although this might kind of look like a normal, and maybe we could put in a few more points right here. We could put points there. There's a bunch of points apparently there. But, and we'll put points, so that's the above one actually, and then this is the below. This one right here correlates to these points. These are multiple points in the same spot. This one right here correlates to that point right there. And there's multiple points because there's multiple observations. So what do you notice about this? If the normal model is appropriate, we should have data at all points. Like there should be data inside of here. But data inside of here, which represents this area, is impossible. And I made a mistake because I can't even give these points that I added on as extra because they're not on the integers. So these points are actually impossible. I don't want my drawing to look not right. That right there, so hard to do the smallest of things. Erase that thing. Really? 2 seconds. Zoom in really good right here, and let's get that to go away. Let's go and do this. Good, and let's go get the green away. There we go. So points inside of this region right here are impossible. But when you look at the curve says that data points should be inside of here, that you should have misses inside of there a certain percentage of the time. If the residuals are well estimated by the normal curve, integer values cannot possibly follow the normal curve values because the normal curve is a continuous distribution. So these integer values was discrete, and the normal curve is continuous. I'm totally continuous. Close enough. So the normal curve is continuous, and the integer values are discrete. So the residuals of the values cannot be well described by the normal curve, but it's close enough. That's where nothing's perfect. All models are wrong. Some are useful. Classic right there. So this model is not doing exactly what we want. Does this kind of make sense right here? It's a very, very tough first question to start, I do admit. It's a theory-based question, and it literally leads to, well, all models are wrong, but this model works all right. It's still wrong, though. So it's kind of the extension of it. Does that make sense here, Ryan? That the residuals cannot possibly follow the normal curve pattern because the residuals are discrete-based, and they will lead to discrete values under here, and it's a continuous distribution. Really good question. That is a very, very tough question. Did you get the all correlations one? I think this is a lot easier now. Find the 6 strongest correlations, which I think is the next one. So we want to find the 6 strongest correlations. So eval equals false. Yeah, that's fine. And EX3 NFL sorted really equals magnitude. EX3, what did I do? Error symbol encode. Oh, ha 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 ha. Error all correlations. Could not find functions all. Oh no, I need to change that. Hopefully that doesn't stop people. The function changed recently. So all correlations, and let's go here to 1 through 6 of the rows. You can also do it with head of the function too. And now it'll get me the strongest 6 correlations. Oof. And then we're doing, we want interest equals something. Interest equals wins or something, right? Of wins, yeah, wins. Okay, so we don't want all of them. We just want interest equals wins. And so now we take a look right here, and we get the strongest correlations for wins. So we need to make sure to put the interest of wins in there. And it wouldn't be strength, because that'll do it from lowest to most negative to most positive. So this is the wrong answer now, because we get the most negative, most positive. The top 5, did I do top, what's top 5? So I think, but does this make sense right here? What other questions are there? Who else has an additional question about how to do the code or what's going on? There's the top 5, if we want a top 5 or top 6. And we're reporting the top 5 rows. Good job, everybody. Great work today. Oh man, I'm excited for the Kahoot.
Kahoots are so much fun. Hopefully we have a bunch of people watching. A lot of fun. We're going to try to do teams on the Kahoot, which I think you can do nowadays. And so we'll do the Kahoot at 2 p.m. I'll send out a reminder. What other questions are there? We'll finish up the Kahoot today. We'll have the test tomorrow. We've got homeworks. Whew, it's a busy week. Summer school is busy. Great job. It's a lot of work. It's like me saying to myself, reminding myself, oh, it's so busy. You guys are like, yeah, we know, Brian. We're the ones taking the classes. And good job to anybody who's taking, like, I think some people told me they're taking 3 classes. That's a lot. Like 2 classes, 1 class is a lot. This class is a lot. Either of your classes right here is a lot. And then 2 classes is like, oof. 3 classes is, wow. That's, I don't know if I've ever taken 3 classes in the summer in one term. That is quite the amount of work. And so I understand. I'm wondering why I keep hearing. Do I need like shielding around the microphone? Well, if that's got it, we're going to start preparing for the Kahoot. And so, Ryan, do you feel a lot better about this question? I've got a friend who's taken 5. Wait, right now? How's that even possible? You mean like all summer? Do you mean all summer, Jordan? Like all summer, right? Not just right now. Like they're not doing it right now. Like nothing. If they are, I don't know. 5 in 1 term would be crazy. I mean, I don't even know if UT let them do that. You do in 1 month, you would do a whole semester. You could get done with school in 8 months, 2/3 of a year at that pace. You're like, what did you do for the start of the year? You'd be like, oh, I got my degree. You're like, oh, like, what, did you get associates or something? You're like, no, I got a full, I think, right, yeah, 2 more later. Yeah, that's a lot. And that's a full semester at MTSU. Yeah, 3 in 1 term is a lot. And I used to like doing mini term first and second session. I would do 1, 2, 2. So I would do, which is a lot. I would do mini term when I was in school, and then I would do second session and first and second session. I'm playing some balloons down here. All the balloons. Balloons. 1C. Let's look at 1C real quick right here. 1C1 or C1 or C2? Which C? C1? Is it C1 right here? Let's look at C1. Many variables that have the strongest correlations with wins are not interesting to analyze. Obviously, teams that have more touchdowns are going to get more wins. So let's examine the relationship. Include the scatter plot with the regression line, making it with the visualized model, making this manual with the visual model. Is the stream of the points linear enough so that a regression model is appropriate? So we want to use this variable right here and predict wins from it. 2. Okay, let's do 2. Examine the results of the summary of the model, write out the regression equation, but round the coefficients to 2 decimals. Remember to use the actual names of the y and the x. Okay, so we need to make the model first right here. So let's go ahead and make our model. And we're going to store into a linear model. So we need to go lm wins predicted from, not Kroger scaled. What's the name of the variable? What's the variable name? ex1. Oh, let's go here to call names. The easiest way, we can, I think it's like the first one, ex3. This is a throwaway code because I just want, there it is. It's this variable right here. So I want to copy this and bring it up to here. Computer, stop acting weird. And data equals, and let's go here to ex3 NFL, and I think that's got it. So the visualized model for the previous one can be done, you don't have to use the plot function, you just can do that. And we've shown that a few times in class right now, but once again, look through the notes a little bit, make sure you're seeing that all the codes are in there to do all the assignments, and we've done the visualized model a few times right here to visualize our model, and it looks linear enough. It doesn't really have any major problems. If you look at it, mostly it's homoscedastic, it's linear, there's a little bit of an outlier here. Outliers can do anything, hint, hint, hint. And we now want to do a summary of this. So now when we do the summary, what 2 things are we interested in the summary? What 2 things in our output are most interesting to us? The what and the what when we build a model. The what and the what of a linear model are most important to us. What 2 values must we be looking at for the what and the what of the linear model? The linear model, we need to know the blank, and we need to know the blank for the linear model. And I'll give some hints right here. And so I'm just kind of, don't obviously code this in here because it won't do it. We need to know the what and the what.
What do we need to know? Of the linear model, what do we need to know? Uh-oh, silence. Well, that's good guess right there. 20 points, Ryan, right there. Those would be the ways we describe correlation, strength, direction, form, unusual features, and then shape, center, spread is for univariate data. So univariate data, like histograms, is described by shape, center, spread, and then strength, direction, form, unusual features are the 4 ways we describe. So good guess right there. And the 2 things we need to know would be the intercept, and there's the intercept, and the slope. Here's the name. So everything I'm highlighting corresponds to this. And this right here is the name of the x variable. This is the intercept. The intercept is negative. Yep, slope and intercept. Yep. And then this is the value of the slope. So that's the coefficient of the slope. What is the name of my y variable that I'm predicting? Remember, y tilde x comma data equals. This is the name of the y variable. So this is predicted wins. So predicted wins is equal to negative 6.512 plus 0.27 times x1 offensive total yards. Does that make sense right there, Ryan? How to write out the equation using the estimates right here, because this is the estimate of the intercept, which is this right here. That's the estimate of the intercept. This right here. Awesome. Great work, Ryan. Thank you for staying for office hours, hanging out, hearing how to do these things, practicing. And then this right here is the estimate, and this is the name of the variable. Like, that's the name. It's x1, but it doesn't have to be. It can be named whatever. Like, I can make a really, I could change this like next year's wins. Is it spelled like that? It's probably not. No, it's not spelled like that. Let me look at the name of the variable. And wins next dot year wins, which we would never do a model like this. And now when we do the summary, the name of the x variable is this. So this right here would be x1. So x1 is just the name of the first variable in the model. That's got it. I'm going to go finish up preparing the Kahoot, get a little bit of lunch, but I will be back. So I'll be seeing everybody. Remember, bring some test questions. It's going to be 320 versus 474. We see which class wins. So I think we can do Kahoot teams, which I'm really excited about. But that's got it for now. Hey, Jason, let's keep going here. Jason. 5 hours. We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours. This ends now.